So, a very warm good morning to everyone present here, respected dignitaries, resource persons, experts, and research scholars. I'm Vaishali Pathak, and I welcome you all to the 5-day online workshop on data analysis for academic research with R in association with the Assam Royal Global University and IQAC. So, before we formally begin the program, let us play the national anthem. The AIU professionals haven't joined the meeting yet, so let us wait for another 1 or 2 minutes. Once they join, we shall start with the playing of the national anthem and then we shall formally begin the workshop. The inaugural program by playing the national anthem. Thank you so much, everyone.
Madam, you're not audible. Can you make the volume little the higher side? Very low volume, I hear you.
Can you hear me now? Am I audible now?
No, no, not at all. I mean, very slow volume is there.
Okay.
Can you raise the volume?
Ma'am,
Am I
here.
audible? Am I audible?
Yes, yes, you are audible. You are audible, fine.
Absolutely, you are audible very clearly, ma'am.
No, your voice is audible, but uh, the one who is speaking, I'm unable to hear.
George sir, can you hear me clearly, or is there any?
I can hear you. I can hear you.
Ma'am,
Okay.
I think can you just raise the volume in your system?
No, no, it's there. I've already checked.
Okay, okay, okay.
But the sir's volume is absolutely fine.
Okay, okay. I think there is some issue in the university's
Okay, doesn't matter.
speaker.
Doesn't matter.
Okay, okay. Okay. So thank you and welcome everyone once again. Now I'd like to request George sir, Professor Dr. George AP, Coordinator AIU AADC of the Assam Royal Global University, to give the welcome address.
Good morning, everyone. It is indeed a moment of great pleasure and pride for me to extend a warm and cordial welcome to all of you on the occasion of the inauguration of the 5-day workshop on data analysis for academic research with R, jointly organized by the Academic and Administrative Development Center of the Assam Royal Global University in collaboration with the Association of Indian Universities, New Delhi. AADC is a dream come true for RGU. We are extremely thankful to the AIU for establishing the center at our university with an objective to enhance the professional capacities of faculty, researchers, and administrative staff of our university and of other higher education institutions in the country. In today's era of data-driven research and innovation, the ability to interpret, visualize, and analyze data is a critical skill across disciplines. R, being a versatile open source platform, provides an ideal environment for developing such competencies. This program provides a very comprehensive understanding of R. We will deal with introduction to R or R Studio and data structures and management today. We will, over the next 4 days, we will cover advanced data visualization, descriptive statistics and data summaries, hypothesis testing using R, simple and multiple linear regression, machine learning and predictive modeling, time series analysis and forecasting, hierarchical linear modeling, and spatial analysis using R. I'm confident that at the end of this program, the participants will gain a deeper understanding of how R programming can enhance teaching, research, and institutional effectiveness. At the outset, let me extend a special word of welcome to our distinguished dignitaries and guests who have graced this occasion with their august presence. We are deeply honored to have with us Dr. Mrs. Pankaj Mittal, General Secretary, AIU, and Ms. Ranjana Parihar, Joint Secretary, AIU, whose guidance and support have been instrumental in establishing this center and strengthening the academic and professional development ecosystem of our university. It is with great honor and privilege to extend both of them a very, very hearty welcome to the inaugural function. Thank you, Ms. Ranjana Parihar. Hearty welcome to you to this function, ma'am.
Thank you. Thank you, sir.
Professor Alakumar Burrohain, sir, the Vice Chancellor of the Assam Royal Global University, is known for his words of wisdom and deeper research acumen. His role in creating an ecosystem of innovation, exploration, and accreditation benchmarks in our university has been extraordinary. Due to ill health, he is not able to deliver his inaugural address, but has sent his best wishes for the successful conduct of the program. I thank Sir for all his support to the function. I extend a very hearty welcome to Professor Dr. Diganta Munshi, our Registrar Administration, who will be giving the inaugural address in place of our VC Sir. I also extend a very, very hearty welcome to Professor Dr. D.N. Singh, Registrar Academics, Professor Nandita, Dean Academics, distinguished members of the AIU AADC committee, and all the officials of the AIU, and all the deans and HODs of RGU to this function. A warm welcome to our eminent resource persons who have kindly accepted our invitation to share their expertise and insights on art programming over this week. This program is organized for the faculty members and research scholars of the higher education institutions, and I'm happy that a lot of participants have registered for this program from all over the country. Hearty welcome to all of you to this program. I welcome Dr. Aruna Devroy, Ms. Vaishali Pathak, members of the advisory committee, and members of the technical team to the function. Your efforts are highly appreciated. And may this event mark the beginning of many more fruitful academic collaborations and innovations. Let me also extend all other members who have joined from different parts of the country to this function. So once again, extend all of you a hearty welcome, and over to you, Vaishali, to proceed with the function.
Thank you so
Thank
much,
you so
sir.
much. Yeah.
Thank you for a warm welcome address. Now I'd like to request Professor Dr. Diganta Munshi, sir, Registrar Administration of the Assam Royal Global University, to give the inaugural address.
Thank you, Vaishali. Thank you, Professor George. Very good morning to one and all present for this workshop inaugural session. Honorable Vice Chancellor, Professor Dr. Alok Kumar Puragohain in absentia, Joint Secretary of AIU, Madam Ranjana, distinguished academicians of Royal Global University, respected experts, staff members of the university, scholars, and participants of the workshop. The Academic and Administrative Development Center, established at the Assam Royal Global University in collaboration with Association of Indian Universities, will focus to enhance the professional capabilities of both faculty and administrative staff of the university through different training programs. At RGU, the first such training program of 5 days on data analysis for academic research with R has been scheduled from 13th to 17th October 2025. The inclusion of digital transformation is one of the important aspects of such a workshop, which will provide an opportunity to the participants to enhance their knowledge and skills required to undertake data analysis in a research using latest technological tools, thereby creating an opportunity for robust, impactful, and significant analysis of the collected information during the research, which will improve accuracy, precision, efficiency, visualization, and communication, thereby establishing advanced analytic capabilities, better data management, better interpretation, reproducibility and transparency, and integration of multiple data sources, and which will eventually lead to an informed decision making. With these few words, I extend my gratitude and thanks to Association of Indian Universities who have taken this initiative to enhance the abilities, the skills, the knowledges, which is so important to create an appropriate ecosystem to be developed in the educational institution in terms of research and other activities to take the institute or the university to the next level. Thank you, and I welcome everybody for the workshop. Thank you.
Thank you. Thank you so much, sir. Now we had an address by Dr. Mrs. Pankaj Mittal, Secretary General of AIU, but I think due to some prior commitments, she has not joined us today. So therefore, I now request Mrs. Ranjana Parihar, Joint Secretary AIU, to address the gathering. I request ma'am to please address the gathering with your few words.
Thank you, Ms. Vishali. Am I audible?
Yes, ma'am, you're audible.
A very good morning to all of you present over here.
Good morning.
On behalf of Association of Indian Universities, I warmly welcome all the dignitaries from the Assam Royal Global University, Assam, especially Dr. Alak Kumar Gurugaon, He's not here, but he has sent his message. So kindly convey my regards to him. Dr. Munshi, Registrar of the University, and Dr. George, coordinator of this particular program, expert speakers, faculty members, guests, and enthusiastic participants joining us from across the country. And the faculty development program is on the theme data analysis for academic research with R, a very, very important theme in today's scenario. I extend my warm greetings to our esteemed participant, distinguished resource persons. Although many of you are already familiar with the Association of Indian Universities, but for those who are not aware of, give me 2 minutes to talk to you about the Association of Indian Universities. I just want to tell you that the Association of Indian Universities is the largest and the most inclusive apex body in the field of higher education in India. What makes AIU truly unique is that it is the only organization in the world that works not just in the academic domain, but also actively promotes university level sports, youth affairs, and research activities. While international bodies like the Association of Commonwealth Universities and the American Council on Education, these organizations focus primarily on policy and advocacy, but AIU works closely with the universities at grassroots level, strengthening academic standards, supporting students' talent, and building leadership in higher education. In 2022, AIU took this special initiative of establishing academic and administrative development centers for the capacity building of our teachers, that is training of our trainers, what they will take to the classrooms. You know, it was a time when we took this initiative, the time was very difficult, the COVID was there, and our teachers, faculty members, they were finding it extremely difficult as to how to use the technology for classroom teachings or for other things. So AIU took an initiative for the capacity building of our teachers as well as that of administrators, offering training programs designed to develop future ready skills and support interdisciplinary research. And I'm very happy the Assam Royal Global University is our proud partner in this initiative, and we are pleased to partner with them in this valuable initiative. So this is AIU Assam Royal Global University ADC Center. Presently, we have 83 such centers where each center is expected to conduct at least 5 programs in a year. So every now and then I have a program. This is the third program since morning I've been addressing. There were 2 other programs. So from October onwards, there is again in the faculty development programs. All the 83 centers have planned their activities and they are now organizing the programs. The theme of this particular program is extremely timely and relevant. You're all aware that the National Education Policy 2020 emphasizes quality academic research, interdisciplinary learning, and the optimal use of technology across higher education institutions. So one of the significant priorities outlined in the policy is to encourage faculty members and students to develop strong analytical and research-based capabilities, connecting with the power of digital tools and data-driven decision-making. So your program is aligned with the the guidelines given in the National Education Policy. Basically, what AIU is doing, we are promoting technology in each and every stream of the higher education. That's what is the mandate of the National Education Policy. And in today's environment, research is not merely about conceptual exploration, but also about delivering meaningful insights from large volume of data. Data plays a very, very important role. How to manage that data, that's extremely important. So the NEP 2020 calls upon our universities to become not just centers of teaching, but hubs of research and innovation. And for this to happen, faculty members need to be equipped with the latest tools and techniques that can enable them to support their students, research, and contribute to peer reviewed publications and address real world problems through evidence based studies. So, in this context, this particular faculty development program on R programming for data analysis, it's very, very important. As many of you are aware, it's a globally recognized open source language used for statistical computing, data visualization, and advanced research analytics. So mastery of such a tool not only helps in personal research pursuits, but also nurtures academic excellence in guiding our learners towards projects of greater quality and international standards. And moreover, the NEP 2020 strongly advocates the integration of digital platforms and e-learning modules with traditional pedagogy. By aligning ourselves with such policy directions, this workshop will serve as a bridge between classroom teaching and cutting-edge digital competencies, thereby creating academic leaders who are both technologically savvy and operationally sound. So I encourage all the participants to actively engage with the sessions, interact with the resource persons, and apply these learnings not only in their own research, but also in mentoring students and their peers, colleagues. So together, let us strive to the spirit of lifelong learning, innovation, and academic excellence that both NEP 2020 and our institution, Association of Indian Universities, stand for. So with these words, I extend my best wishes for the grand success of this particular faculty program. Thank you. Thank you so much.
Thank you
so
ma'am.
much. Thank you so much for
Thank you. Thank you so much, ma'am, for your enlightening address to the gathering. Now I'd like to request Dr. Aruna Devroy, ma'am, member AIU AADC of the Assam Royal Global University, to give a brief of the program and to give the vote of thanks. A very good morning to all the dignitaries from Association of Indian Universities and the Assam Royal Global University, resource persons Dr. Ambar Datta and Dr. Bikash Borua, and all the participants present here. This 5-day workshop on data analysis for academic research with R will take us through 10 different topics, adding to our knowledge base. These sessions are curated with due care and diligence to give us an in-depth knowledge and information on basics of R and R Studio, data structures and management on day 1, which will be delivered to us by Dr. Ambar from MIT University and Dr. Bikash from the Assam Royal Global University. The other topics include advanced data visualization, descriptive statistics and summaries, hypothesis testing, regression analysis, machine learning and predictive analysis, descriptive statistics and summaries, and time series, spatial analysis, to name a few. These sessions will be delivered by professors from Guwahati University, Dibrugarh University, Assam University, Delhi University, and ICMR. It is mandatory for all the participants to join all the sessions and take maximum mileage out of it. From our experienced set of trainers from the vast array of academia. All the participants will be communicated both through WhatsApp and email. Thank you and wishing all the learners an enriching learning experience ahead.
Thank you. Sir, please allow me to leave. I have to join another program.
Thank you so
very
much, ma'am. Thank you so much,
ma'am.
ma'am.
Thank you,
Thank you
ma'am.
so much.
Thank you,
Yeah,
ma'am.
thank you so much.
Thank you so much, ma'am. Thank you, ma'am. And thank you, Ranjana ma'am, as well for your address. And now, without any further ado, we'd like to begin our workshop with the first session. So, before I request our resource person for the first session, Dr. Ambar Datta, I'd like to give a small briefing of Dr. Ambar Datta before I ask Sir to take over the session formally. So Dr. Ambar Datta did his BSc Honours in Mathematics from Presidency College, Kolkata, and MCA and PhD from Jadavpur University, Kolkata. After serving in the Department of Computer Science and Engineering, Birla Institute of Technology, Mesra for 15 years, he currently works as an associate professor at MIT Institute of Information Technology, MIT University, Kolkata. Dr. Datta authored a book and has published more than 50 papers in reputed national and international journals and conferences. His research interests include image and video processing, data analytics, machine learning, information retrieval, network security. He is an active reviewer of many reputed journals like Pattern Recognition Letters of Elsevier, Multimedia Tools and Applications of Springer, IET Image Processing, etc. He is also a senior life member of various professional bodies. So with this, I'd like to request, sir, we welcome you all to this 5 days online workshop on art. So now I request sir to take over the session from here.
Thank you very much. Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. So good morning to all of you. And I thank the university to invite me for delivering the session on R programming, introduction to R programming. As I do not know the backgrounds of the participants, I assume that some of the participants may not be from the computer science background. So I started the session from the very beginning. I will, it is a very basic topic like introduction to R and Art Studio. So I will give a brief introduction of R, then I will go for hands-on exercises of various concepts of R. I will give a overview of different topics, which will be covered in the next few days with you also. So with this, I begin today's session. Ma'am, I am unable to share my screen. Can you please do something?
Sir, do you have a PPT with you?
Yeah, I have.
Sir, you please open your PPT and then you share the screen in the Zoom.
No. It is mentioned that whenever I'm going to share it, it is shown that host is disabled participants screen sharing.
Okay. Just a second. Sir, I have.
Okay. I got it.
Yeah.
Is my screen visible now?
Yes, sir, it is visible.
Okay. Thank you, ma'am.
Yeah.
Okay. So the topic of my talk will be on the introduction to R and Art Studio. Art Studio is basically the IDE through which we write the R program. So basic concepts of R, it is basically a programming language which was developed in the early 1990s, and it is mainly built for doing complex data analysis, doing some statistical analysis, doing some visualization, some advanced data analysis, many things. It is mainly meant for statistical data analysis, R programming. It is very much popular. And the major important criteria for its popularity is it is open source. It is easily available. It can be downloaded from the internet and you can make use of it. Now, these are the various applications. They are the various applications. Why it is very much popular? It is a complete statistical language. You can do anything with any statistical calculations with R programming. It has huge set of libraries. You can connect with other programming languages also. It is open source. You can, and it is very easy. It is very easy. Most of the most important part is it is very easy. Our programming language is very easy to learn and work with. Now, all these things I already told. It has a huge set of library, large package repository. Like in the C programming language, we have the live header files. In Python programming, we have a set of libraries. We have a huge set of libraries for different types of works. And this is comprehensive R archive network is the basically I'm busy. No. So this is the comprehensive R archive network with the official website for R, from which you can get the corresponding downloading option of R programming, R Studio, and Basic R. We have various kind of library. A very important library is the ggplot, which possibly you will learn whenever you will learn various kind of data visualization things. You have a full session on data visualization. I believe you will learn ggplot library on that one. And you can do various kind of machine learning work as well as correlation regression, time series analysis with the help of various libraries of R programming. I'm not going into the detail of this. The advantage I already told, but disadvantage is it is comparatively slow. If you compare with Python programming, the same kind of things, if it is a very large data set, R often performs slowly. That is the one of the biggest disadvantage of R programming, because it consumes huge amount of memory. And regarding the error handling part, it has less support as you find it in its counterpart of Python programming. I'm not going into the difference between R and Python. That is not a part of this talk. Now, RStudio is basically the IDE for our GUI. GUI means graphic user interface, and we use RStudio to write the programs. There are various. If you look into the RStudio, you will find there are various parts. You will find the left-hand side part is called the console. Then the right hand side part is the environment or the history, and the lower right side part is the files, plots, and everything. Just a minute. I believe the screen is still visible. Please respond. The screen is still visible? Yes. Okay, fine. Thank you. Thank you. Okay. Now, why do we use R Studio for writing the program on R? Because it is a very user-friendly interface. You need to write your program in the console part. In the console part, you will write the program. In the environment part, you will find whenever you are writing any program, you are using some variables. What are the variables you are using? What are the value of the variable? What are the comments you are using? All these things you will find in the environmental window. And whenever you are talking about the file, plots, packages, help, this kind of window, in the files window, you will find out what are the existing library. I will show you whenever I will open the RStudio and I will start writing the program. You will understand what are the meaning of the different parts. Plots means what are the different plots? What are the different plots you have used for your current session? You will find it. And the packages is what the install packages available in the present version of R. Now, as I told you that the console part where R waits for us to enter comments. We write the program, we write the comments in the console part. On the right hand side part is the environment history panel. Environment panel shows all the variables that have been created during your programming session, and history keeps track of all comments what we have used for the current session. For the current session is very, very important. Whenever we close the session, again we will start a session, we will not be able to see it. So for working with R, you need to get a working directory. Like all of your files, all of your programs has to be stored in your working directory. Now, what is your working directory in the R program? In the R, you can get it by the getWD function, get working directory function. If you write get working directory after installing R in the console, RStudio console, you will get the path what is your working directory. Now you can change your working directory also. You can change your working directory also. So with the help of the first way is with the help of setwd things, setwd function. Setwd within double quote, you just write down the path in which you want to store, you need to assign your working directory. So getwd, you will find what is your current working directory, and if you want to change your default working directory, you can make use of this setwd function, and it is very, very important because all of your programs, all of your files has to be stored in this working directory. Once you have written something in the console, you can clear the console with the help of Ctrl+L command. Whenever you are writing something, I will show all these things whenever I will go for the hands-on part. and you can clear the console with the help of Ctrl+L, and you can clear the environment, like what are the different variables you are using, all these things with the help of this command. RM, that is remove, list, it is a list of, ls is the list of all the variables. Now, once you are working with any programming language, you require some variable which will hold some values. So these are the very basic things of any programming language. It contains some variables, it contains some comments. It has a comments means if you want to disable some comment which you do not want to get executed, you can make it as a comment. Or if you want to make user-friendly program, then whatever you want to write in a particular line, you can write a comment like why you have written this one. So basically the variables are used to store data, comments are used to improve code reliability, and keywords are the reserved word which have certain specific meaning for a particular programming language. A particular reserved word may have, yes, a particular reserved word may have certain meaning for a particular programming language, but it may have different meaning for different programming languages. Now, whenever we want to assign some value to a variable, these are the three assignment operators. One is the normal simple assignment operator. This is called the leftward assignment, that the less than and dash. And rightward assignment is very, very rarely used. It is the dash greater than. Dash greater than means whenever we write x equal to 2 means 2 is assigned to x. Whenever I am writing a less than dash b means the value of b is assigned to a, kind of things. I am not going into the details. I will do the hands-on. Like whenever we want some part of your program to stop from execution. Suppose you have written 100 lines of codes. You want, that is the 95th line should not be executed. So you can make the 95th line a comment, so that that line will not be executed. Now there are different types of operators: arithmetic operators, logical operators, relational operators, assignment operators. Logical arithmetic operator is addition plus subtraction, multiplication, division, exponentiation, and it is a remainder. This is binary and binary OR. This is logical and logical OR, and it is not. Less than equal to, relational operator, greater than equal to, and not equal to. And for assignment operator, we can have equal to or less than dash. Keywords, there are various keywords: if, else, while, for. All these are the example of keywords: function, next, break, which has some specific meaning. Now there are various kind of data types: numeric, integer. Numeric means it can be a set of real numbers. It can hold decimal numbers like this. Integer means it is solely integer, set of integers. Logical, true or false. Complex number, there is a complex data type also. Character means single character. There can be string data type, which will be list of characters. Now, how can we take input from the user? You can make use of the read line command. Whenever you want to write anything in the read line command, you like, suppose I want to get any number, so I will write read line, enter any number. Now whenever you write var1 equal to read line, enter any number, in your console you will find enter in number is displayed. Whenever you write something over there, that something will be assigned to the variable var1. And if you want to convert the data types of any variable, you can make use of this functions as integer, as numeric, like this. Now, there are various control statements. Control statement means that is the logical statements like if then else statement, looping statement, for loop, while loop, kind of. Repeat break statement. Repeat means we are skipping the execution for the current value of the variable, and break means we are coming out of the loop. These are the basic syntax of various control statements. If condition, then we write executable codes over there, depending on the problem statement given to us. And then execute it. If else is there. If else means if the condition is false, if the condition is true, then the first set of statement will be executed. If the condition is false, then else part will be executed. There is a concept of if else if ladder. If we have condition 1 true, then this part will be executed. If by any chance condition 1 becomes false, then second condition will be checked in the else if part. And if it is true, then second set of condition statements will be executed. Otherwise, this code will be executed. Now, in the for loop is for executing the same set of codes repeatedly. Executing a same set of codes repeatedly. This is called a loop. Whenever, suppose I want to print the first 10 natural numbers, so I need to print every natural number one at a time. So I need to do the same thing again and again. I need to print a natural number. I need to print another natural number like this. So I will write a same code or same set of statements over here, and I will vary the natural number for getting printed. Break statement, as I told you earlier, it is used to terminate a particular loop for further execution. And next statement means it discontinues the current iteration and proceeds to the next iteration. And while statement is also there, while loop. The basic concept is basically the same. Now, there are various data structures which are used. In the next session, you will learn about the various data structure in detail. But without knowing the data structure, I cannot proceed. That's why I just give a very brief idea of different data structures. The first important data structure is called the vector. What is vector? Vector is a collection of similar data. Similar data means it is all integer or all characters or all floating point numbers. Vector is the set of similar data. Or everything is mentioned over here. R vectors is same as the arrays in the R programming, and it can hold the multiple data values of the same type. It is not possible that you are in a vector you are storing logical data, numeric data, character data. It is not possible. If you have such criteria, then you have to go for the lists. List is the similar kind of vector. It can hold a set of values, but the type of value may be different. That is the difference between vectors and lists. Vector can hold only the similar data, and list can hold multiple data types. Matrices. Matrix is a two-dimensional representation of data. Again, The same difference between matrix and data frames. Matrix, it is a two-dimensional representation of data which can hold the similar data types. But the data frames can hold multiple type of data. It is again the two-dimensional representation, but it can hold multiple data. Now, how can we create a vector? We need to define a variable, and with the help of C within brackets, a set of values, you can create a vector. C is used for to combine. This C is a function. It basically combines all these value to a single variable X. That is the use of this C. And you have to write like this. There are other options also. You can make use of the ACQ functions. It is a sequence. Sequence from, what is the meaning of this? If you write sequence 1 to 10 only without this length dot out part, then it will store 1, 2, 3, 1, 2, 3 up to 10. Now, once I write length dot out equal to 5, then the length of this sequence will be 5 only. It will start with 1, end with 9, but the length will be 5, right? So it starts with 1, end with 10 means that distance between first and last number is 9. This 9 is divided by 4. Why 4? Because between 5 numbers there are 4 intervals, and those 5 numbers are equally divided by the same ratio. Now whenever I write 9 by 4, I get 2.25. So you can find in the output, it is 1, then 3.25, then 5.5. Each of them are equidistant, and distance between each term is 2.25. Why it is 2.25? Because it is the distance between this 9, and since the length is 9, length is 5, between 5 number there are 4 intervals. So 9 is divided into 4. And you can make also use of this colon operator. Whenever you write z equal to 2:7 means z will hold all the numbers from 2 to 7. So these are the various options for creation of any vector. Then I am not going into, it can be logical vector, character vector, numeric vector. Length of the vector, you can get it with the help of the length function. You can access a particular element in a vector with the help of a square bracket. And you can also modify a vector. You can sort a vector with the help of the sort function. If you use sort function, it will by default sort it in the ascending order. If you want to sort it in the descending order, then you can make use of the second argument, that is decreasing equal to true. So this is the very simple. Only you need to know the functions and apply it properly. Everything is available over here. You do not need to do anything. But many things is automatically done by the various functions of R. Now, as I told you, list can hold different types of data in one structure. So we can combine various different types. Like I can add 2 characters with 2 integers. It is a valid list. I can update the first element from apple to mango. If I write list 1 equal to mango, so apple will be replaced by mango. I will show you all these things whenever I will go for the hands-on part, and the majority part will be the hands-on part. Majority part of this session will be the hands-on part. Let us try to go for the hands-on something. I have talked many things. Let us go for some hands-on. I believe my this screen is also visible to all of you. This is
visible. Visible,
yeah.
sir.
So this is basically the art studio stream. This is basically the art studio stream. So as I told you, this side is the console part. This side is the environmental part, in which you after some time will be able to see many things. And this is the files, plot, packages, kind of this. Since I have not plotted anything till now in the current session, I'm unable to see anything over here. But once I plot something, it will be available over here. These are the list of packages which are already installed. And this is the extra part which I have not yet discussed. Like this is you can write program separately, because once you write any command, it is not stored. If you want to store the comments properly and document it, then you have to write the programs as an R script. This is called R script, and you can write R script over here and you can store it. Now, suppose as I told you, suppose I want to store something in a variable. Suppose I want to create a vector. I want to create a vector. Let us write x is the vector name, which is equal to, as I told you, x c. Randomly, I put some number 1, 2, 3, 4. So once I press enter, you see in the right hand side part, in the environmental part, this is the variable name, and these are the values which the corresponding variable holds. And what is the data type? It is a numerical data type. And how many values it is storing? It is 1 to 4. If I write y is equal to, say I write ACQ, or I write 2:7, 2:6, press enter. You will find another variable I have declared, y, which starts with 2, end with 6. Starts with 2, end with 6. And how many numbers are there? There are 5 numbers: 2, 3, 4, 5, 6, starting with 2, end with 6. So these all are the lists. These all are the vectors. Sorry. Another part, what I told, suppose z equal to, I am making use of ACQ function. ACQ, say 1,6 or 1,7. If I write this one, this means fine, there is no problem. ACQ 1,7, it holds a number starting from 1 to 7. But if I want to make Z1 1,7, and what I told you, length dot out, right? If I write length dot out, and you can see it is very, very helpful. Like whenever I'm writing length, what are the possibilities I may write that will come out? Equal to, say, I write 5. Now, if I write this one, length is 5, right? Length is 5. What is the length of the interval? Length of the interval is 5. And what is the difference between the highest and second lowest value? It is 6. So 7 is divided, this 6 is divided into by 4. Why by 4? Because my length is 5. So whenever 6 is divided into 4, the individual interval will get 1.5. 6 by 4 means 1.5. That's why I'm getting 1, 2.5, 4, 5.5, 6. So all these things I have already described. Now, how to take input from user? this is with the help of equality operator, I can assign some value. Now, if I write x1, suppose x2 is a variable name in which I want to print the square of the values of x. So I will simply write x into x. I will simply write x into x. Now, once I write this one, you will find in the x2 variable is automatically there, which is nothing but the square of the corresponding values of x. So if it is simple, if in other languages you may I need to write a loop for this, but over there it is very simple. You simply write x, some variable equal to x into x, the corresponding values of x are getting squared and getting stored. And if you want to print it over here, you can write print, say x2, then it will be stored over here also. Earlier you see all the variables, its reflection in the environmental window. Now if you want to print in the console, you can also print it. So this is one part. Now I told about matrix, right? I told about the matrix. What is the meaning of the matrix? Or I am just writing, just a minute. I'm writing x1 equal to 7. Suppose I write x1 equal to 7. At present, my x equal to 1, 2, 3, 4, right? I'm writing x1 equal to 7. Look, now my x becomes 7 to 3, 4 because I have modified the first element of the vector by 7. Earlier it was 1, now it becomes 7. I believe all of you are understanding what I'm saying. Please respond once. Okay, thank you. Thank you very much.
So we are getting responses in the chat
Okay,
box.
thank you. Thank you very much. Thank you. I have seen it. Okay. Now, suppose I want to write something in the art script. What should I write? What should I do if I want to write an art script? Then I need to click on file. Then it will come, and then in the new art file, I just write the art script. This is my blank art script. Now in this I can write anything. Anything means relevant thing regarding a particular program. Suppose I want to check whether a number is even or odd. I want to check whether a number is even or odd. So what do I need to write? Suppose even means it is divisible by 2. Odd means it is not. So I have to make a decision. So I need to make a decision means I need to make a conditional statement or control statements. Like I need to make use of if-else statement. I need to make use of if-else statement. So first of all, I need to accept a number from the user. So what should I write? Before writing this one, if I write, suppose if I write say say y1 is a variable, y1 equal to read line double quote, enter a number. Enter a number. If I execute it, you will find this kind of prompt will come, enter a number. Now, whenever I write 5 or any number over here and press enter, you will find a new variable is created y1 with 5 value. Right? You will find a new variable is created with the value 5. But if you notice, this 5 is coming in the double quotes, means it is as if it is an integer, as if it is a character. But I do not require character for this. I want this 5 to be an integer. So I need to change the types. As I told you, I need to change the type. So what do I need to write? Suppose I'm writing y2 is equal to as dot integer. As dot integer, then I write y1. At present, I do not have any y2 over here. Now, once I write this one and press enter, you find y2 is generated with 5 as an integer. It is a long integer, that's why it is written as L. So with the help of as something, we can change the data type of this variable to data type of my desired variable. So whenever I require any integer, so I will make use of this. I need to accept any number. I need to make use of readline, but you have to keep in mind that whenever you are using readline, the corresponding value, whatever is you want to, suppose you want to store integer, but it will treat the entered value as character. So you need to make the modification in the data type with the help of as integer function. No, so I need to make use of an odd function, right? Or I need to make use of one thing I told you. Suppose get wd function, right? Get wd function. If I write get wd, this is this one, and you can make use of your own. You can make use of this one, set r programs. Suppose I make use of this one. So I have modified. I have modified earlier my get wd, that is a working directory, was in the downloads documents part. Now I changed my working directory to the R programs folder in the D drive. So in this way, I can make changes in the working directory. Now, whatever I will write, whatever the code I will write, I will store in this folder only. Whatever the data I will use, I will store in this folder only. Now, suppose I'm writing an R script. I'm writing an R script, which is, suppose I need to check whether a number is even or odd. So n equal to readline, I need to accept from user readline, enter a value. And as I told you, whenever I write enter a value and execute it, it will be a character value, but I require an integer. So I can write n equal to as integer n. So whatever the value I store over here, the same thing will be, or I can make use of other variable also if you want, but m will also definitely work. It will be overwriting of the values. Now, for checking whether the number is even or odd, I need to divide the number by 2. So if the division is, if the remainder is 0, then it is even, otherwise odd. So I write if m is the corresponding integer, right? I should not write n over here because m is the integer equivalent of the number which you have entered. So I write m %, 2 double equal to 0. Single equal to is the assignment operator, double equal to is the equality operator. Then I start writing print. I can write even. Later I will do some other calculation or other things also. Else print odd. This is the thing. There is a simple program to check whether a number is even or odd. Then I save it. It will be saved in a folder, in this folder, that is in the D drive R programs, which is my folder. Say odd even. I just name the function name as odd even. Save it. Now I have saved the function with odd even and it is getting saved. Now if I run it, you find this function, this program has run. Like an extension of R program is .r, right? That you need to keep in mind. So enter a value, we get enter a value. Then if I write 5, it will print odd. If I write 5, it will print odd. Again, if I execute it, and in this part, if I write 10, it will give you even. So my program is correct. So it is giving yes and no kind of things. Now suppose I want to do some customization, like I need to print that instead of writing only odd or even, I need to print 5 is even or 5 is odd kind of statement. So what do I need to make? What do I need to do? I need to make use of a paste function. Paste, P-A-S-T-E. Whenever I write paste function, paste, then I'm writing M, comma. It is basically the concatenation of 2. M is even. And in this case also I'm writing paste, bracket, M, comma, is odd, bracket properly. Done. Now I save it. Then I rerun it. Again, you get enter a values prompt. Now, if I write 7 over here, you will find it is printed 7 is odd. So it is basically you are making your program more readable. Like everybody will understand what you are trying to do. So whether n is even or odd, you will get to know. Again, if I do this one, if I write 16, it will print 16 is even, like this. So this is one part in which I make use of a simple function. I make use of a simple function now which is stored. Earlier, whatever I write in the console, I write simply a command to get the result. Now this is the first thing what I write, like I have written a program, R script. Now it is getting stored as odd even.r. Previous things was not stored. I was only getting the results by writing a comment. So that is the difference between R script and writing in the console. Next part, suppose I will need to make use of, say, suppose there are 3 integers. There are 3 integers. I need to check which one is the highest. Which one is the highest? So like in this program, I require only if and else. Whenever I want to check for 3 integers, like we are given with 3 numbers, I need to check which one is the highest, just print it. Then what should I write? What should we do? So let us do that one also. It is, suppose again I am doing. So whenever I told this one, like n equal to read line, enter a value, and then as integer n. So in this case also I can do the same thing. So I write read line, enter the first value, enter first number. First number. Then I write a is equal to as dot integer a. Similarly, I will do the same thing for second, third, and fourth, second and third number. I just simply copy and pasting this one, copy and pasting. Then I will rename the things. B is the enter the second number, enter the second number. Then B is equal to as integer B, and C is equal to the third number, enter the third number, and C is equal to as integer C. Now, once these three lines are there, so I can take input for the three values. Now I need to check. So what do I need to do whenever I want to check whether which one is the highest among the three numbers? I need to compare between A, B, C. So I write if A is greater than B, and means it will be this AND, logical AND, right? And A is greater than C. So if A is greater than or equal to both, if A is greater than both, then definitely A is the highest. Then A is highest. So what do I need to write? Print. Say I write paste function, paste A, comma, double quotes, is highest. So paste double quote, one bracket, second bracket. Okay, fine. Else, you have to be very, very careful about these brackets, because if there are mistake in the arrangement of brackets, the entire effort will be 0. Else if condition is B greater than C, then just copy paste the thing, Control C. Then I write B over here. Else C is the highest. This is my program. I accept the number. Then again, I need to highest. Suppose my program name is highest. So data type as R, highest.R. Now I save it. Now if I execute this one, you will find enter the first number in the console. Suppose my first number is say 7. Enter the second number, let it be 9. Then enter the third number, let it be 4. Right? Now once I do this one, once I press enter to this, you find 9 is highest. So it is an application of, if earlier a program odd even was the application of only if else. This is an application of if and else if and followed by else. That is, I need to check two conditions. And the first condition, this is a combination of two conditions, and of two conditions. If both of them are true, then only the result is true. So this is the thing. Now, let us come to the second part. I told you that suppose A is equal to, say C, say 4, 6, 1, 8, 3. Now, if I print A, I will get these values 4, 6, 1, 8, 3. Now, if I write, say, sort A, what will you get? It is getting sorted in the ascending order. By default, it is ascending order. Now, if I write sort A, I want to get in the descending order. So what I told, I need to write decreasing equal to true. So once I write this one, you find the values are stored in a decreasing order. So it is all about your requirement. Whatever you want to do, you can do it over here. Any kind of this kind of work. So sorting, it can be the sorting of characters also. It can be sorting of integers also. Suppose I take another example. Suppose A is equal to this one. Suppose AB. Suppose BD. Suppose CG. This is my B variable. So fine, there is no problem with. Oh, let us do one more thing. Add one more thing. Let us add one thing, that is. Let us add one more thing, that is, hold on. First of all, I'm writing RG, and then I'm writing one more thing, that is say ED. So this one. This is my B. So if I print B, I get these values. Now, if I write sort B, execute, it is getting sorted in ascending based on the first character, right? And if you want to sort in the descending order also, you will be able to do it. If you want to, if you press the up arrow in the console window, you will be able to see what are the previous core statements you have executed, right? Whenever you press the up arrow in the console window, you will be able to see what are the different codes you have written. Now, what I told at the beginning, if I press Ctrl L, then this console will become vacant. If I write Ctrl L, if I press Ctrl L, suppose I'm pressing Ctrl L, so these will be there, but all my console statements will be removed. Let us press Ctrl L. You see the result. Everything is done. We are not able to see anything. It is stored in it is there in the history. It is there in the history, but I am unable to see them. It is clear. For clearing the console, I pressed Ctrl L. And in the history tab, you will be able to see all the statements what I have used till now. In the history tab, you will be able to see all the statements which I have used till now. Now, suppose I want to clear the environment. What statements I use there? I make use of rm bracket list is equal to ls. Now, if I press enter, my environment becomes vacant now. I believe you are able to see, right? Students, participants. I believe you are able to understand what till now I am doing.
Yes, sir, it's visible.
Okay, okay, fine. Next, let us go for matrix. I told you the matrix is a two-dimensional structure of similar elements. Suppose I am writing matrix. I write matrix. Then I write the elements which I want to store in the matrix. Suppose I want to store 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 6 elements only. And I write number of row equal to 2. Number of row equal to 2. N row equal to 2. Once n row equal to 2, by default, my number of column becomes 3 because 6 element 2 row means there should be 3 column. No need to write n column equal to 3. So once I do this one, you see, we have created the matrix. But once, if you notice clearly, then the elements are stored column wise. That is 1, 2, then 3, 4, then 5, 6. Right? Whenever I want to store 1, 2, 3, 4, 5, 6 in 2 rows, so it is stored first of in the first column. These are called, this is the row, this is the column. Column wise, it is the elements are getting stored. Now, suppose I want to store the value row wise. What should I do? What should I do? There is one more argument called by row. There is one more argument called by row. I will write by row equal to true. Once I write by row equal to true, then press enter. You see, the elements are stored row wise. Earlier it was 1, 2, 3, 4, 5, 6. Now it is 1, 2, 3, 4, 5, 6. So it is totally your requirement if you want to store the value row wise or column wise. If you want to store the value column wise, just ignore the by row statement. Otherwise, if you want to store them in row wise, then it will be by row equal to true. Then suppose I want to create a diagonal matrix. So I will write diag. Which value I want to store? Let it be 4, 5. What is the order of the matrix? If it is diagonal matrix, it is always square matrix. So if it is 3, 3, so see, elements are stored where the diagonals are all 1. Diagonals are all 1. Now, if I want to store different element at the different diagonal, so you can make use of this statement. Suppose I am writing diag C1, say 4, 9. So if I write this one, then write this one. So you will find in the first row, first column, you will get 1. Second row, second column, you will get 4. Third row, third column, you will get 9. So this is the basic things. These are the basic things which you can do it, which you can check. Now I told about the loop also. I talked about the loop also. For loop, while loop. Let us do one program with loop. Let us do one program with loop. Let us do one program with loop. So I need, since I will write a program, I need to write a or script. Suppose I want to check whether a number is a prime number or not. I want to check whether a number is a prime number or not. So what do I need to do? Whether a number is prime or not. So again, I will start a new script file, starting from this new script file. Then what is the nature of prime number? A prime number is divisible by only one and that number. If it is divisible by any other number, then it is not prime or composite. This is the criteria of any prime number. So if I write, suppose I accept a number n equal to read line, enter a number, double quotes, enter a number. Then I need to modify, I need to change it to integer because as integer n. Then how will I check? How will I check whether a number is even or odd? Oh, sorry, prime or composite? There are many ways. There are many ways of doing this one. One of the simplest ways is to keep counting the number of times it is divisible by any other number. So I just write one variable count, which is assigned to 0, which is assigned to 0. Now I write for I in 2 colon n minus 1 n minus 1 for I equal to 2 colon n minus 1 means I will, if I write 2 colon 5, if I write 2 colon 5, then you will see the values are 2 to 5. So if I write I in 2 colon n minus 1 means I can hold the value 2 to n minus 1. Then I check if the number n is divisible by I or not. Then I write c equal to c plus 1. Then I write break. Break means once I find that it is already divisible by any other number, I do not need to divide it by any other number, right? So I write a break statement over here. Then at the end, after the end of the for loop, I write if c equal to 0. C equal to 0 means what? C is not incremented. C is not incremented means this result is not true for any such value, means it is a prime number. So I will write this equal to print. I am not going into the paste now. I simply write a prime and not prime. Prime, else I can decorate the results, but at present I do not want to. Print composite. Then let us save it with some number, say prime number is a prime number 1. Now let us run it. Enter a number. You find enter a number. Now if I write say 15, if I write say 15 at present, again, your environment tab is empty, right? Because I have cleared it. Once I press enter, you find again things have started. So 15, it is a composite number because it is divisible by 3. It is divisible by 5 in addition to now if I write a 17, then it will print it is a prime number because 17 is a prime number. So this is another program in which I have make use of a for loop. I have make use of if statement also. Combination of loop structure and control structure. So these are a small program you can always write in your. These are the small program you can always write in R. Now suppose I want to use a library function. I want to install a library. I want to use library function to check whether a number is prime or not. So if I want to use a library functions, I need to install a package. In order to install a package in R, you need to make use of install.package. Install.package. Now, whatever the problem is, you need to know the name of the package before using it. So for this, I require the package name called numbers. So once I write install.packages is for numbers, it is installed. It is installed. This package is now installed in my working directory. Now, once I install a library, I need to call the library. What should I write? I need to make use of the library function. Library numbers. So this is done. So I call the library. Now I simply write is prime. Is prime. Is prime 15. Is prime 15. Answer is false. If I write is prime 17, answer will be true. Like this. This means with the help of, I do not need to write any program. If I know that this function is available, only I require to use the library and call the function from that library. Right? So if you know the library, if you know the functions which you can use, then often you may not need to write the code. Just calling the functions will be fine enough. Suppose I want to print all the prime numbers between 1 to 50. So I will write primes 1, 50. Between 1 to 5, it will print all the prime numbers. So these are the list of prime numbers. So only the thing is you need to know the functions. You need to know the functions and make use of it. So this is what we have. In the later part, I will talk about some other data types that is called, though again I am telling you like this is the introductory lecture. You will get to know about all these things in detail in your future specific sessions. Next, again I share this one. Again I go back to the PPT once. Again, the screen is visible.
Yes, sir, it's visible.
Yeah, thank you. Now, I already talked about the matrix and all those stuff. Now, next important part is the data frame. What is this data frame? Data frame is basically a kind of table in which I have, suppose I want to store the student data. I need to know the student roll number, I need to know the student name, the other details, maybe in which city they belong, what is the current CGPA. Suppose these are the things I need to know. So for that, I need to make use of a data frame. Data frame is a tabular structure which may have different types of data, but each column will have similar data. First column 1, 2, 3, it is maybe a roll number. Suppose it is a student data I want to store. I want to store the roll number. I want to store the date name. I want to store the CGPA they got. Right? Suppose I copy this line. Suppose I copy this line. No, not I will copy. I will go back to my R string. Share the window. So what do I need to do? Suppose I want to create a data frame. Let us do it in, again, I just clear everything. Control L. Let's start from the beginning. So for data frame, suppose df is the name of the variable. Df is for the data frame. I can write anything, d, d1, d2, anything, xyz, anything is the name of the variable data frame. So data.frame, then suppose forget about data frame. Suppose the first one is, say, first field is, say, roll number, which is equal to C, can be 2, 5, 9 kind of. Second field is the name. Name will be a string. I take a random name. Let it be AB. Next name is BC. Third name is CD. CD and EF. 3 students. And third student is maybe EF. And I want to store their CGPA also. CGPA, which is equal to C equal to 8.3, comma 7.8, comma say 8.1. This one. Then if I press enter, sorry, I took some, again there is some bracketing mistake. 6.1 data.frame. This one. I write EF after the double quote, right? So there is no point of any mistake over here. So roll number fine, name fine, and CGPA fine. Now it is okay, I believe. Now if I press DF, you will find this kind of things. If you want to print DF, you will find this kind of things. Like there are 3 roll numbers, 3 names, 3 CGPA. Now if I want to get the structure, of the data frame, I will simply write strdf. So you will find the details of it has 3 observations with 3 variables. First variable is a numerical variable with containing these values. The details of the data frame are returned by this function. If I want to get the summary, if I want to go for the summary df, so this is the what is the maximum value, minimum value, all the details will be shown over here. All the details will be shown over here. Now suppose I want to extract only the roll number. How should I extract the roll number only? So for that I need to write df and press the dollar sign. There are many options. First option is, suppose I want to extract a roll number, means I am writing this one df. Since roll number is the first column, I will write df1. Press enter, you will get only the roll number. What is the second option of printing roll number? Again, I will write df bracket, again another bracket. Within that, you need to write roll number or roll. Then if I press enter, you will get 259. The third option is how to print df. Then whenever you press dollar sign, you will find the list of arguments. That is roll number, name, and CGPA. Whatever you want, let it be name. Press enter. You will be able to print all the names. So this is how to access individual attributes from a data frame. So if I want to get roll number, I will write df roll number. If I want to get the CGPA, I will write CGPA like this to print this one. Now suppose I want to extract, or suppose I want to add one more column to it. Suppose I want to add one more column to it. How should I do it? What should I do it? Suppose I want to add one more column. Suppose another column is, say, city in which they reside. What should I write? I write df dollar city. Then I write C. Suppose I write a proper name. May it be Kolkata, may it be Delhi, may it be Chennai. So these are the 3. df city. City was not there. At present in my structure, I only have 3. Now I entered this one. Now if I print this df, you will see this city has come, which was not there earlier. Now suppose I want to get the details of all the students whose CGPA is more than 8. Suppose I want to get all the students whose CGPA is more than 8. What should I write? Suppose I'm writing result, anything, a variable r equal to df, subset, bracket. First of all, from where you are getting df, and what is your criteria? df dollar CGPA is greater than 8. Suppose I am writing this one, right? So once I get this one, then if I print r, you will, at present your data frame contains all 3 values, right, with 4 attributes. Now whenever I write this statement, r will contain only two values, because the second candidate, roll number 5, had the CGPA less than 8, so it will not be counted, because I wanted to get the result of all the students whose CGPA is more than 8. So I can get like this, right? Who reside in Kolkata? I can say like this. So city double equal to Kolkata. If I want to write subset df city equal to double equal to Delhi. Then if it is R, you will find only those student who reside in Delhi. So this is how we can work with data frames. This is how we can work with data frames. Now, let us talk something about the visualization. Let us talk something about visualization. That is plotting different types of graph. Plotting different types of graph. For plotting different types of graph, the important function over here is plot. Plot function, PLOT. Now, if I write PLOT, then 2, 3, 2, 3, 2, 4, 2, 5, or 1, 3, anything of your choice, and press enter, you find this kind of structure where you find like this is the structure. It starts from 1, 2, 3. 2, x coordinate is 2, y coordinate is 3, and you can see this point. You can see this point. It is simple. It is simple. Like suppose I want to plot 2 points. So what do I need to write? Plot. Say I'm writing 2, 3, comma, I'm writing C 4, 6 or 4, 5. So if I write this one, means the two x values are 2 and 3, two y values are 4 and 5. So it will plot the value 2, 4 and 3, 5. Then if I plot this one, you will find two different plotting. One is at 2, 4, one is at 3, 5. Now, if I want to do some plot more than 1, 2 points, if you want to plot more than 2 points, what can I do? Suppose I write x equal to, suppose I want to plot say 5 points. I write 1, 2, 3, 4, 5, and y values are let it be 6, 2, 5, 7, 4, 6. Suppose these are the y values. Then I write plot x comma y. Now, if I plot, how many points I am plotting? 5 points. What are the coordinates? It's only 1, 6, 2, 2, 3, 5, 4, 7, and 5, 4. So these are the 5 points. 1, 6. First point is over here. Second point is this. Third point is this. Fourth point is this. Fifth point is this. Now, if you want to increase the size of the circles, then you can make use of a parameter called CEX. If I write CEX equal to, CEX value is by default 1. So if you want to double it, you can write it like this. So you see the value of the size of the circle has enhanced, right? Now, if you want to change the shape of the points, suppose I am writing, then you need to make use of another attribute that is called PCH. PCH is equal to say 3. If I write PCH equal to 3, this PCH value can take any value between 0 to 25. It can hold 6 different possible values. So if I write PCH equal to 3, it will be like this. All the points are plotted as plus. If I write PCH equal to 2, it will plot like triangle. All the points are plotted as triangle. PCH equal to 0 means it is circle. Right? If I do not write anything, if I do not write CX, then the triangle will be smaller triangle. With CX equal to 2, triangle was bigger triangle. Now, suppose I want to do it properly, right? As at present, I get X and Y over here. Suppose I want to do some more customization in plotting. I want to do some more customization in my plotting. So suppose I want to do, say, suppose I want to change the color. Suppose all the equal to, say, blue. Then you will find all the triangles will come in blue. Though it is not visible properly, but it is actually blue because I have written blue over here. I believe if it is red, you will be able to understand. If it is red, you will be able to understand. Let me check it once. Red. And now I think it is understandable. Now if I write CX equal to 2, now if I write CX equal to 2, it will be bigger circle. You will be able to understand. It is a red circle. Now, again, if I want to do other kind of things, like I want to write some label, X label. Label means whatever I want to see in the X-axis. Suppose the X-axis. X label is the X-axis. Suppose I write, suppose up to this one only. Suppose up to this one. I print it. You see, the X-axis is plotted over here. Then suppose I write Y lab equal to, Y lab means Y level of the Y-axis. Y lab equal to the Y-axis. If I print it, they will find Y-axis is over here. And next, if I write the main attribute, main, that is the title of the main equal to, say, plotting of points. If I write this one, then plotting of point will be the header of the image, plotting of points. So you can do whatever you want to do. You can do whatever you want to do with this plot function. Whatever I talked about, it is simply, you can plot a single value, single point, multiple points, with different shape of the point, different size of the point, different color of the point, with variable labels. You can do the things. Then suppose I need to plot a pie chart. Suppose I need to plot a pie chart. You know, pie chart looks like a circle kind of. I believe all of you know. Yes, no. Suppose I want to plot a pie chart. So for pie chart, I have the pie function. For drawing a pie chart, I need to make use of a pie function. Suppose my value of the variable is x is equal to, say, say 10, 20, 30, 40. 10, 20, 30, 40. This is my x. Now, if I simply write pi to comp within bracket x, you will find a pie chart. And whenever you're going into the plot tab, in the plot tab, you will find the list of all plotting which you have done till now. In the plot tab, you will find a list of plotting which we have done till now. If I press back arrow, I keep getting the points. I keep getting different plotting. At present, I am at pie chart, right? So pi x means these are the values. With the help of simply pi function, I can make use of this pie chart. Now, suppose I want to start at a particular position. Like you see, your first thing starts with this point, right? First section starts with this point. Suppose I want this to start with at 90 degree. So what will I write? I will simply write one simple statement that is called init dot angle. Whenever you write init dot angle is there, and that is equal to, if I write 90 and press enter, you will find this one will go upward. So your plotting starts from this point. Earlier in the previous one, your plotting started at horizontally. Now your plotting started vertically. Now, but if you do not write anything, it is typically start horizontally only. Now, suppose I want to use some labels. That is what is the meaning of each slices of the say of the different sectors of the triangle. Suppose label, I write, suppose I write A, B, B, I write C, I write D. Since there are 4 components, I need to write 4. And then if I write pi x label equal to that lab, whatever I have written, then 1, 2, 3, 4 will be replaced by ABCD, right? So it is much more understandable. Like suppose this is the export of different countries in amount. So if the country name is there, one can easily understand which country exports how much amount of the commodity. Now suppose you can change the color of the circles. You can change the color of the circles. How? Suppose I write colors. Since there are 4 such things, I need to make use of 4 colors. So I write C. Suppose I start with blue, then yellow, then green, then red. Right. Again, I make use of this one. Label will be there. Then now I am using col is equal to colors. Once I write this one, and once I press enter, you see the color of the circle are modified. depending on the options you have given. For D, it is red. For C, it is green, kind of, along with the labels. Suppose I want to, sometimes in the pie chart, you often find some percent sign is mentioned. How many percent of the things are there? So you can clearly calculate the percentage. You can clearly calculate the percentage. Suppose I do the percentage calculations. Percentage equal to, say, around 100, because my x variable is holding the values 100 into x divided by sum x, comma 1. Then I do, in the label part, I do a simple modification with the statement called paste. LAB, comma, double quote, comma, then double, then PCT, comma, then double quote percentage. This is for the formatting only. There is nothing comes out of it. You see, for which part I have how much percentage, I am able to print it. So if A contains 10% of the data, B contains 20% of the data, like this, total should be 100%. So in this way, you will be able to plot pie chart. And one last thing, you will go in the details of all these things. You will go into the details of all these things with the help of various sessions which are planned in the workshop. Then finally, I talk about do you have any question? Because the session is almost towards the end of the things. Do you have any question to ask? Otherwise, I will proceed with some new part. Because it is a very, I make it in such a way that you will be able to understand the meaning of each things. I try to do the hands-on so that you, if you make the coding like this, what are the changes you are getting, you will be able to easily understand. I believe the session is understandable till now. Now, with the help of the SEM, you can easily draw the bar plot also. Bar graph is also available over here. In the bar graph also, we will be able to get the values for different attributes. And suppose number of in a basket there are different number of fruits. So if I want to plot them as bar graph, like this one only. Suppose in one variable I have x abcd, in one variable I have 2 3 4 5. So if I want to plot these values as a bar chart, if you want to plot a bar chart for this, what should I use? I will make use of the function called bar plot. Bar plot, the bar plot, my y variable value, that is I want to plot in the y variable the x values. So it is x, and I will write names.arg is equal to lab. If I write this one and if I print it, you will see a bar graph is plotted. It is very simple. Only you need to get to know the functions. This is very simple. If you want to make use of different colors for different, again you need to make use of col equal to colors, because it is already available. I have already declared the variables. So if you write like this, you will get it like this. Now sometimes we require some legend kind of. Sometimes we require some legend. So if I want to write some legend, what should I write? I will write a statement called legend. Then where I want to plot the legend. Suppose I want to write bottom right. I want to put the legend in the bottom right. Then left, then fill equal to colors. Fill equal to colors. Now if I do this one, you find a legend will come over here. Legend will come over, like blue means A. Often you find these kind of things in many drawing. So if you want to add some legend, you can draw it. If you want to add x-axis, y-axis, you can make use of this. You can make use of, I'm just copy pasting this one. Plotting of points. If I write like this, then you will find this kind of things. X-axis comes, y-axis comes like this. So this is how we can plot the bar graph. This is how we can plot the bar graph. You can, for a set of values, you can calculate the mean, median, mode. For a set of values, you can calculate standard deviation variance with the help of various statistical measures. Suppose you are having x is equal to, say, C 1, 2, 3, 1, 3, 4, 1, 7, 5. How many values? 1, 2, 3, 4. I write one more value, 2. So this is my weight. So if I simply write mean x, with the help of mean x, it will be able to calculate the mean of the values. Mean means average. With the help of median function, you can make use of median calculations. This is the median. Median is the middlemost value. Middlemost value means 50% value are greater than it, 50% value are less than it. But there is no straight cut functions for calculating the mode. Mode is the most frequent value. You can calculate standard deviation. Standard deviation is a SDX. This is the standard deviation value. Variance is the square of the standard deviation. This is like this. But if you want to calculate the mode, there is no straight cut functions available for calculating the mode. So what you need to make? You need to go in some other way. Suppose I write U is equal to unique x. Unique x means suppose U is equal to unique x. So if I write this one, what U contains now? 1, 2, 3, 4, 7, 5. All the repetitions are removed, right? Over here, 1 occurred 3 times, 2 occurred 2 times, 3 occurred 2 times, remaining elements are occurring only once. So all the repetitions are, so I can find out what are the different unique elements. Then what do I need to write? U square bracket which dot max bracket tabulate match x comma u. This means for which value to which value u is matching most of number of times in x. U values are like this, x values are like this. To which value of x u is matching most of the times. Once I press enter, you will find 1. So 1 becomes your mode. Because 1 occurs 3 times. So it is your mode. So in this way, you can do the simple statistical calculations. You will learn about the regression, linear regression, multiple linear regression, simple linear regression, correlation between the variables. There are a lot of pre-existing data set available in R. Empty cards is one of them. Empty cards is a pre-existing data set, right? Miles per gallon, cylinder size, displacement, horsepower, weight, all these attributes are there. It is a pre-existing data set. There are many pre-existing data sets available over here. So you can make use of this data set also in case you want it. So with this, I conclude my session. It is already 12:58. Do you have any question to ask?
Yes, participants, do we have any question? So the session was very enriching. You started right from the basics. So somebody who has no idea of what it is, how to go ahead with it, that will be very easy to cope up. So if the participants are having any query, any question, our learned professor is here. We can ask sir the queries, the questions, and clear our doubts. You can unmute yourself and you can ask. That will be better because you might take time to put down the words in the chat.
Otherwise, you can take down my contact details. You can directly contact me. I believe my screen is available, visible to
Yes,
you.
yes, it's visible. It's visible.
So if you do not have any question, then you
We
may
can
ask
wind
later
up the
also if
session.
you want.
Yeah. So we can wind up the session as we have no questions from the participants, the chat box, or nobody's unmuting. So thank you so much, sir. It was a very good, very enriching, and I mean, somebody, as I already mentioned, a beginner will be very much. It's helpful for a beginner to cope up. So this kind of session was very much required, as especially social sciences students, we don't have much idea. We want to use multiple softwares, but then we are not exposed to it much. So this session will be a really enriching one, really helpful. And in case of any doubts, any queries, participants will contact you in your email ID. Your contact number is also visible here. Thank you so much, sir, for joining. In the
Thank you very
future,
much.
we wish to host you again. Thank you so
Thank you
much.
very much.
Okay, for the participants, our next session will start at 2 o'clock sharp, and Dr. Bikash Barua will take up the session. So, all of you join back after your lunch at 2 o'clock in the same link. You can keep yourself logged in, or you can log out as well, and you can, log in again at 2 o'clock if you're not logging out. This is the same link which we'll be continuing in. Thank you so much.
Oh, so I'm leaving.
Yes, sir. Thank you so much.
Thank you.
Okay, a very good afternoon to everyone present here. I welcome you all back to this 5 days online workshop on data analysis in research using R. So now we shall begin with our second session of the day, which is on data structures and management. That will be delivered by Dr. Bikas Barua. So before I hand over the session to Sir, I'd like to read out a short profile of Sir. Dr. Bikas Barua is currently serving as an assistant professor in the Department of Computer Science and Engineering at the Assam Royal Global University, Guwahati. He obtained his PhD from National Institute of Technology, Arunachal Pradesh in the area of bioinformatics, where he extensively used the R programming language for data analysis and computational modeling. He completed his MTech in Computer Science and Engineering from Northeastern Regional Institute of Science and Technology, deemed to be university under the central government, securing a gold medal for outstanding academic performance, and earned his BTech in Computer Science and Engineering from the same institute. Dr. Barua has over 9 years of teaching experience in reputed academic institutions. He has published more than 15 research papers in reputed international journals and conferences. His research interests include bioinformatics, data analysis, and machine learning. In this workshop on data analysis using R programming, Dr. Barua will deliver a keynote session on data structure and management, focusing on efficient data handling, representation, and manipulation techniques using R. So with these few words, I'd like to request Vikas sir to kindly take over the session. Over to you, sir.
Thank you. Thank you, madam. Good afternoon, everyone. I'm Dr. Vikas Barua, working as an assistant professor in Royal Global University, Guwahati, Assam. So first of all, it's a pleasure for me to be here as a part of this faculty development program on data analysis using R programming. So I would like to thank the organizers for inviting me to share a few thoughts on one of the most fundamental aspects of R, data structure and management. So in this session today, I'd like to, first of all, I'd like to go with some theoretical aspects of data structure, how data structures are important, how it is implemented in data analysis portion. And after that, we'll go, later on, we'll go for the hands-on parts also, so that everybody can get in depth of every type of data structures. So, madam, I think some of the candidates still have to be joined. So, can you wait for a few minutes, or we can continue?
Yes, I think we can wait for another 1 minute
For
and then.
Hello, am I audible to you?
Yes, sir. Yes, you are audible. So your video and audio gets stuck in between sometimes. I think sir is facing some network issues, so we can wait for 1 or 2 minutes as sir will join back. Sir, your audio is turned off. Uh,
Okay, okay. Uh, okay, now am I audible to you?
yes, 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 sir. Yes,
Okay,
sir. You
okay.
are.
Sorry for interruption. Actually, my internet was disabled. Okay.
No
Uh,
problem.
okay, I'm sharing my slides. Okay, is it visible?
Yes, sir. Your screen is visible.
Okay. So today's now this is session is data structure and management. So before going to the in-depth of this session, data structure and management, I'd like to say a few terminologies, that is data, information, data structure, and management. What are these terminologies actually means? What is data actually? So because most of are already known, most of you have already know these things, but still I would like to say a few things about data and information. Suppose in our railway management system, let's say one example of a railway management system. In the railway management system, for one day, whatever the data is there, suppose how many trains are there, how many total stations are there, how many people are going to be get in every stations in each train, and how many people are going out or drop in from each station. So the collection of all these things for a single day, this is the database, and the consist of all the things in that database are the data. But all these things are not information for everybody. So information is, in our book's definition, it is written as it is a process data. So what is basically process data? Say for me, I'm traveling in the same day from station A to station D through the train, suppose AB. Now, the timing, the train AD will come to station A and reaching to station D will be only these things will be the information for me, but these things may not be the information for other passengers. So that's why that is the process data, it is the information, and the complete set of all these things is the data. So now when we do the data management or data analysis, our main objective is to find out some information from a huge amount of data. That's why first of all, I'm telling the definition of information. So why we need the data structure? Why we need the data structure? So data is the foundation of every analysis. So structure determines the clarity and efficiency. So let's take one picture. So this one, let's consider this one. Here is so many things are there in a drawer. And similarly, let's consider one more. Let's consider one more drawer. Almost similar type of things are there in both the drawer. One is the right side, one is the organized one, but the left side one is not organized one. So whatever the inside in the drawer, we can consider it is a data. It is a different data. So now data is the foundation of every analysis, and structure determines the clarity and efficiency. If we store the data with some clarity, with some efficiency, then only we can do a proper analysis with this data. Otherwise, it will not be possible to get an efficient result from our unorganized set of data. In our computer memory, we can compare our computer memory like this drawer. It is a container. So in that container, how we store the data, that matters. That is the different data structures are there. Through that structure, using these structures, we can store the data in different ways according to our needs and according to our importance. Let's consider one more picture. So this room is completely unorganized. So this room is more unorganized, but a similar type of things, if you organize this one, it will be something look like that way. So now we can get a clear picture that from a organized things, if you want to do if you want to find something, then it will be easier. So that's why in our context of our computer memory also, if you store the data in an organized way or in a structured way, then it will be very easy. It will be very less time consuming to find some data, to do some analysis. Here in the previous diagram, if you want to do some analysis using such kind of data scattered here and there, it will not be possible to do some efficient analysis. Suppose if you are, I'm asking you to find something from here, and after that, after finding 2 hours, 3 hours, you will not be ensured that whether this, if you don't find that element, after 2-3 hours also, you will not be ensured that actually whether the element is there or not, because this is an unorganized thing. But when it is an organized thing, then you will search in the specific position. If it is there, then it is okay. Otherwise, if it is not there, then it will not be in the entire room also. So I'm trying to say something relating these things from the real life examples, because in computer science, all these concepts, all these theories are basically influenced from our practical life scenarios only. So now come to our directly computer science point of view. So in computer science point of view, there are different languages, and different languages have their own different data structures. So nowadays R, Python, these are very well-known languages, and these are very widely used languages. These are used for data analysis, in fact, in machine learning, deep learning, in all these things. So why these things are very widely used? Because these languages offers very flexible and powerful tools compared to our previous languages, earlier conventional languages like C, C++. Compared to these things, R, Python, these languages are offering very much flexible and powerful tools with less effort from the computational point of view. Am I audible to everyone?
now we can hear you.
Okay. Actually, I'm not getting any response. That's why I was
Yeah.
confused.
I
So,
request
okay.
all the
Oh,
participants.
oh, oh.
If,
Okay. Thank you.
yeah.
Okay. Okay. Thank you. So, why focuses on data structure? It affects the speed and memory uses. First of all, if you store the data in a structured way, the very basic thing is it affects the speed. If it is a structured data, it will give very higher speed of everything, and memory uses will also be less. How memory uses will be less? Suppose in our in a container, suppose in a real life container, if you randomly put some things, put some different things into the container, and somebody is inserting the same things in an organized way from one corner of the container, then hopefully that organized way it will be able to accommodate more things in the container. In the same thing, if we think in point of computer science, then how memory uses will be less. Suppose we already know that computer memories are like a small partitions. Suppose a computer one data that is consist of 10 bytes, and you have another one data that consists of 12 bytes. Suppose from the indexing 1 to 10, you are storing the 10 byte data, and randomly after that, from the space, from the index of 13 or 14, you are started storing the second data. Now, just imagine that in between these two data, you are keeping, you are just wasting 2-3 bytes of the memory, because in that small size of memory you will not be accommodate anything in future. Instead of doing this, if you store the data from suppose first one 1 to 10 byte, then immediately from the 11 bytes, index 11, if you start storing the next data, then if you organize like that way, then memory uses will also be efficient. So that's why that if you maintain the proper structure when doing the machine learning or deep learning things, data analysis, then it it will acquire less amount of memories. It ensures the reproducibility also. If you store the data in a structured manner, then it will be understandable for everybody. Everybody can understand what type of data is this, how it will be stored, and from your contents, from your data, anybody can reproduce, or anybody can reproduce such type of analysis in another experiments also. So in our data structures, we'll go through a such kind of performance. That is, first is the data collection, then data cleaning, then data analysis, and finally the reporting. Reporting means finally what information you are getting. So in this session overview, first we'll go for the core data structures, different data structures, and different data management and transformations. Next, we'll go for some case study and best practices and reproducibility. So good data structures leads to a good analysis. Till now, this is the main motive. Whatever I am saying, the main focus is that good data structure lead to a good analysis. Without a good data structure, if you don't store the data in a proper structure, analysis will never be efficient or effective. So that is the pipeline for data analysis, data collection, structuring, management, and visualization. So now let's begin the exploring of our data structures. What are the different data structures available in R? So I hope you have already familiar with the R Studio, because in the first session, I have seen that basic things are already covered. How R Studio, what are the different facilities are there in R Studio. So in the same RStudio, we'll go for the next things, that is the different data structures. Since I have already told that every languages supports different data structures. So R also have some specific types of data structures. So we'll go one by one, all these data structures. So these are the different data structures supported by R, that is vector. This is the very simple and very basic data structure. The next one is the matrix, array, data frame, table, list, then time series data. Time series data structure is also very important nowadays. Then is the next data structure is the vector. So these are the in general data structures supported by R. So vectors, the vector is the basic building block. It is said to be as the basic building block. What is the definition of vector? It is a sequence of elements of same type. You can store here same type of data in a vector, and it creates using the function that is C and bracket. So this is the function used for creating the vector. So example said x is a one variable, that is user defined variable, and in that variable we are storing this vector. The first one consists of 4 different values, 10, 20, 30 and 40. Then we have one more variable y. This y variable also consists of one different vector, consists of 3 different values, cat, dog, abc. So let's these things I think already it was shown in the last session also, but for the flow of all different kinds of data structure, I'm starting again from the vector. So now let's go to the RStudio workflow. Let's try to run these vectors. So is it RStudio screen is visible? RStudio screen is visible? Yes, no? Okay. So, so now first here, the complete RStudio screen is divided into 4 different parts, 4 different, the left side, top one, here you can write the program and you can save it, whatever you want to run the program. So in the, here you can see here different tabs are there. I have some, all are different programs. There's just below that screen in the left side, this one is the console. Here you will, when you run it, here you will see the output, as well as if there is some error is there, these errors will be also shown in the console part. And you can, after that, you can do the debugging where it is the error. And in the right hand side, the top one is the environment part. Here you can get whatever the data, whatever the variable you will declare, all these
Sir, our
variable.
screen is not visible, sir.
Ji sir.
It's not visible to our screen, sir.
Yes, the RStudio screen is not visible. Only your PPT we can see.
Okay.
Yeah.
Then let's say, now is it visible?
Yes, sir.
Yeah.
Okay. So you have already know that this RStudio window is divided into 4 different parts. Left side, 2 parts, top and bottom. And the left side, the top one, here you can write the program and you can save it in your computer hard disk. And in the below one, that is the console part, left hand side, below one, that is the console part. Here you can see the output, whatever you are running, as well as if you are getting any error, then also it will be shown in the console part. In the right hand side, top one, that is the environment section. Here you can see different variables what you are declaring, because vector, matrix, data frame, whatever the data structure you are declaring, these are basically one on variables only. So all these variables will be shown here once you started running the program. Once you run, that variable will be stored here or shown here actually. And after that, the last part, that is the right side bottom part, this one is the for you if you want to install some packages, okay, or if you want to plot something, so it will be shown here. So now go to the program. So I think you can see this. So here the first statement I have written here, x is assigned as, this one you can give a single equal also, or like that symbol also, left side arrow, both will give the same meaning. So here I'm creating one vector c 10 20 30 40. So for running each statement, you have 2-3 different ways of running this program. One thing, you can select the complete statement and click to the run. Here it is run button, click to the run. You will see here in the console part, you can see here it is okay, there is no error, so it is directly running. And in the right hand side, in the environment part, you can see here x variable is declared here, and the values you can see here 10 20 30 40. Okay, and one more way you can run the same thing, the same statements I'm running. Just you click in the statement anywhere in the statement and you run it without selecting also. If you run without selecting, then also it will be running. Here also you can see it is running in the bottom here 10 20 30 40, again it is running. And one more, that last way of running, that is the for individual statement. If you click on this, or you can click or you can select, and if you press control and then enter with from the keyboard, press control and then enter, then also it will run. Here you see x is okay. So these 3 things you can do for running. And one more last thing, if you want to run the complete entire program, then you can do control A, select all these things, then you press this run button, or you can press control plus enter. Okay, so this is the things. So now if you want to see the value of x, here I'm writing the variable x, then I'm pressing control enter. Here in the console panel in the below, here you can see the values 10 20 30 40. So quickly go to the next vector y. So I'm selecting this one, y vector. Let's try to run it. So here you can see in the right hand side, environment variable phases y, and in the console also you can see cat, dog, abc are there. If you try to see the output, just type y and then press enter, then you can see cat, dog, and abc. So now the last one, z. Here you can see that I'm combining here categorical data as well as the numerical data. So in the definition of our vector, it was telling that it can consist of a similar type of data, but here we are combining the different types of data. Then what will happen? Will it show any error? So let's try it. It will not show any error. So what happened, I'll tell you. If you combine both the things, then this 78, then 89, 90, these will also be considered as a string only. This will not considered as a numerical value. So let's run it. This is z. Okay. Here you can say z is executed. This statement, z statement is executed. Variable z is created. Then if you want to see the values of z, then just type z here, then run here, only the z. Okay. Here you see in the console panel, this cat, it is in under double quotation. This 78 is also in under double quotation. It is inside the double quotation. That means it is a string. It is not a numerical value. Here you can see when I was executing 10, 20, 30, 40 for the variable x, in that cases 10, 20, 30, 40 does not have double quotation. So that means these are numerical values. When you are doing analysis, these things generally create very, very chaos. And that's why I'm for very beginning, I'm clearing to all these small things. So now this 89, 90, if you do the next performance 90 plus 1, it will not be executed because 90 is now becoming the string. Okay. So for suppose Z3, if I execute Z3, then only that this third value, this dog will be printed. Let's run Z3. Yes, you can see. So this is the very basic buildings of vector. So I think now vector is clear to you, how vector can combine only the single kind of data. If you combine categorical data as well as numerical data, then complete data will be considered as a categorical data or strings. Okay. So now come to the next type of data structure, that is the matrix. So matrix is a 2D collection of data, that is rows and columns. Vector was a 1D. So matrix can be written like that way. Here say we are writing M. Okay, M is one variable we are declaring for matrix, and for creating that variable as a matrix, you have to write the function matrix, matrix, and inside the parenthesis you have to write these arguments 1 to 6. 1 to 6 is the values. You can ignore this also. If you don't write 1 to 6, then all the values will be initially considered as a NA or invalid. So number of row 2, number of column 3, that will be, there are 6 different cells will be there. 2 into 3, 6. So total I am writing here 6, 1 to 6. All the cells will be stored with 1, 2, 3, 4, 5, 6 like that. So generally matrix is used for numerical and mathematical operations. So let's go for the operations for matrix also. Let's switch to RStudio. So I think RStudio is visible to everyone. So here, next type of data structure, that is matrix. So we are creating one matrix M. This is the statement. So let's execute it. So here you can see that in the initial statement M, matrix number of row 2, number of column 3, here in the environment phases, you can see here NA, 6 times NA is showing there. That means 6 different spaces are created for a matrix M, but each spaces are now initially it is a blank. So you can create a matrix by initializing the values also. So in the next statement, we are doing the same thing by here we initialize the values also. So let's execute this one. M1, this M1 is created. Here you can see this M1, 6 different values are stored here. 1, 2, 3, 4, 5, 6. So here, one thing I want to say, the same thing, let's do one different way. Say M2. Say M2. And if I write here, say 1 is to, suppose 4, 1 is to 4, then what will happen? Then you know what will happen. For the initial 4 blocks, 1 to 4 will be assigned. Then after that, again the values will be repeated from 1. Let's see. If I execute this statement, So here, one thing I'd like, I forgot to say. So here, if you do 1:1, then all values will be repeated like that. For all these spaces, 1 1 1 1 will be repeated. But if you, when I'm trying to give 1:4, then this time it is not accepting these values. 1:4, it is not a sub multiple or multiple of any number 3. Okay, so that's why if I take the sub multiple of 3, say 3, then what happened? Now it is executing. You see, now it is executing 1 2 3, then again 1 2 3. So matrix has some limitations also. So for this such kind of limitations, we'll go to the next type of data structure, that is data frame. So it is more versatile than matrix. Here you see, when I put 1:3, then initial 3 values are 1 2 3, then again 1 2 3. But when I put 1 to 4, then it is not working. Okay. So now if I try to check M1 to 1, that means which value will be there, M1 to 1. So this one is our M1 value, that is 1 2 3 4 5 6. Okay. So if I execute M1 to 1, it is printing the value 2. So there is one difference between, very basic difference between C and R. In C programming, since it is showing 1 2 3 4 5 6, if you write the index M1 1 comma 2, then only the second value will be displayed. But here in R, if you write 2 comma 1, then only it is displaying the value 2. The difference is that C by default it follows row measure order, but R by default it follows the column measure order. So if you print M1, you can see here, I'm just printing M1. Here you see how 1 to 6 is printing. First it prints the first column 1 2, then it goes for the second column 3 4, then it goes to the third column 5 6. But if you do the same thing in C, then it will be printed as a row measure order. So first 1 will be printed, then in place of 3 2 will be printed, then in place of 5 3 will be printed, like that way. So here it is a very basic things, you should keep it in your mind while doing the data analysis. So R follows by default the column measure order. So this is a matrix. Okay, so for generally for mathematical operations only, we prefer the data structure matrix. So next we go for the next type of data structure, that is the array. The next type of data structure, that is array. So array is a multi-dimensional extension of matrix. Okay, so array can consist of 2 dimension, 3 dimension, 4 dimension, 5 dimension, any number of dimensions can be occupied in a array. So conceptually we can, so definition, so in the directly go to the last statement of the PPT. This is the statement for declaring an array. This is a little bit quite different than a vector and matrix, but using the array expression, using the syntax of array, you can declare the vectors as well as matrix also. Though R is providing different data structures, different structures or syntax for vector and matrices, but just a minute. Excuse me. There is some session is going on, please. Though vectors and metrics have different types of syntaxes, but we can represent them in the syntax of array also. So that's why conceptually we can say that a vector is an one-dimensional data structure, or we can say that vector is an one-dimensional array. Or matrix, we can say that matrix is a two-dimensional array, and array is a generalization. It can have 2 dimension, 3 dimension, 4 dimension, 5 dimensions. So we will do the practical also. So how to represent vector using the array syntaxes, okay, and for matrix also. So here we can see that this one is for array. So we are declaring here one array. The function name you have to write as a array, array, and after that we have to declare the dimensions. So how many dimensions here? This C322, these are not values. Well, when we are declaring a vector, then inside the C function, if you write some numerical values, these are actually values. But when you write in array C322, these are not values 322, these are the dimensions. Okay, how many rows, how many columns, and in 3 dimensions you can say how many heights, or like that. These are the 3 different dimensions. So if you execute this statement, this one, here you can see that in the environment phases, A 1 3 1 2 1 2, these are all how many
Sir,
values can be stored? Yes,
sir, it's not visible, sir.
this okay, I think I have. Now it is visible.
Yes, sir. Thank you, sir.
Okay, after that I will not switch to the slide also. I'll directly continue with this because every time switching to slide and here actually some swing problems. Okay. Now where we were here in this statement, you can see here we are declaring one array. It has 3 dimensions, C322, 3-dimensional. So it will have 12 different cells, or 12 different memories are occupied by this array, by this variable A, because 3 into 2 6, then 6 into 2 it is 12. So when you execute this, here you can see in the environment A, all the spaces are initially NA like that. But here we can do things. You can insert the values also while declaring. Array 1 to 12, we already by the dimensions we can see that how many values can be stored in that array, because 3 2 2, so it will be 12. So 3 into 2 into 2, so 1 to 12 we are taking the values. So in this dimension, if you execute this one, this A1 here in the right hand side in the environment phases, we can see here there is 1 2 3 4 10 and 11 12 will also be there. Or we can, for overviewing the, you can write here also A1. If you write A1, then if you execute just the A1 in the console panel, you can see the values. Here you can see how these arrays are creating. Initially 1 2 3 4 5 6, then 7 8 9 10 11 12. Like that way these arrays are storing. So from here, say if A1 1 1 1, for this index, which value from the console, you can see here all these values are stored in a two-dimensional array because 3 dimension cannot be visualized here. So that's why it is showing in a 2-dimensional spaces with 2 different 2-dimensional arrays. So if you run A1 111, then it will show which values? It will show the values 1. The first value, this one. The first value, this one. It is showing. If you write 2 1 1 1, sorry, 2 comma 1 comma 1, then if I select this one, just clicking here also you can do the run. Then you can see here it is showing the value 2, right? If you change some values, suppose 3 2, then 3 2, then 1, then 3 2, then 1, that means this value, last value of this first 3-dimensional array. First one, this one is the first part, this one is the second part, because here we are taking the third dimension as a 2. If you take third dimension as a 4 5, then like that way more values will be there. So because this one is 3, this one is 2, so 3 2 1, that means the last value of this one. So if you press here 3 2 then 2, then it will show the last value of this one, because 3 2 is the last index for this array, because 3 rows and 2 columns. Okay, so now this is the array representation for 3 dimension. So now let's as I have already told that matrix and vector can also be represented using the array syntaxes. So just can you recall how we declare the matrix? Here you see matrix we declare just by number of row and number of column. This is the syntax for matrix. Now we will declare 2 dimensions using the array matrix using array syntaxes. So array syntax, you no need to write the number of column, number of row. You have to write here dimension. In place of this dimension, if you give only 2 dimensions, suppose 3 2, now this is a 2-dimensional array, or this 2-dimensional array you can say as a matrix also. See this one, I have this MA. Now I have executed this one, this MA is executed. Here you can see MA, this is a MA values are stored 1 2 3 4 5 6. The same thing you can do the syntax of matrix also. So here you can access the values MA 2 comma 1, then MA array 1 comma 5, dimensions 3 2. Here you see these things. That was the limitations in our matrix. When, because in our matrix you can remember that there are 6 different spaces. When we give the values 1:4, in that cases it was showing error, but array is giving this flexibility. Here I am inserting 1:5 and it is working. There is no error is showing here 1:5. How the values are assigning here, you can see MA1, this MA1 values are 1 2 3 4 5 comma 1. Again it is repeating from 1. If you change here say 1:4, then it will also be executing. Say here 1 2 3 4, then 1 2, again it starts repeating. Similarly 1:1, then all value will be 1. If you remove this part, then all values will be given as a NA. So similarly for you can declare a vector also using the array syntax. Here only you have to declare the dimension, only a single dimension. So this one C10 we are writing, that means 10 different values can be stored here. Okay, so VA we are writing here. So this 10 is not value, this 10 is the size. Okay, so if you run here VA, we are taking the variable as a VA. So here you can see VA, all the values 1:6 we are taking. So 1 2 3 4 5 6, then 1 2 3 4, it is repeating again. These values are storing in these 10 different memory spaces. So now you can Now we have gone through three different kinds of data structures, that is array, matrix, vector, matrix, and array. So array can accommodate any dimensions. Vector is a unidirectional or single direction. Matrix is a two-dimension. So now come to the heart of the analysis, R programming analysis. That is the data frame. Data frame is said to be as the heart of data structures in R programming. Without knowing the data frame, nobody can do an analysis in R programming. So data frame is also one kind of similar kind of data structures like array, but with some additional features. Because of these additional features, data frame becomes the most useful data structure in R languages. Okay. So how you declare a data frame? You have to declare a data frame using the function data.frame. Okay. In vector, we are writing only C. In matrix, we are writing the complete word matrix. In array, we are writing the array. And for data frame, you have to write data.frame. And what are the arguments will be there? Arguments, first argument, you have to give the name. That means it will be the column names. And here, these are the two different values for these are not the sizes. Now in here, these are the values for A and B. So let's execute it to this one. This one you see here df, we are writing here df. This df is the generally why we write df. This is just a short form of data frame df. That's why generally most people used to write the variable name also df, but this is not required. You can give any name. When we will go for the actual programming with using the data sets, then there you can see we will give different names that have some specific meaning, because variable names should also give some meaning, so that later on after 1 year or after 2 year when you open this program, then also it should be understandable for you that by just you should get some hint that what this variable name is meaning. Okay, just giving a name like abc, temp, such type of variable name you should not in the professional program writing, you should not give such type of names. Now this is for practice point of view, we are writing the df. So how this df is looks like, by clicking here also in the environment phases, by clicking here also you can view. I am clicking here in the df, you can see here this name and age. Name and age, these are the two column names here. This one name and age, and for this name, this one is one vector, and for this age, this one is also one vector. Okay, for name, this ab is consists of one vector, and age 23 25 consists of one vector. So in a data frame we are combining two different vectors, right? So like that way, so here in matrix generally what happen, or array generally what happen, it consists of only numerical values. But in data frame you can combine categorical data as well as the numerical data also. Like that way, one more program, let's see this one. This one is a complete statement from here to here. So df1, here we are taking df1. This one, for df1 variable, it has three different columns: name, age, and marks. And we are just giving the values for name, giving the values for age, and giving the values for marks. So if you execute it, see here, two observations and three variables. So here you can see that name, two observations, age, two different observations, marks 90 and 85. Okay. So how many observations are there? Two different observations, 1 and 2, two different observations. This is called one observation, this is called one observation, and three different variables. One variable is name variable, another variable is age variable, and another third variable is the marks variable. All these things are combined in one data frame that is called, we are naming as DF1. And for viewing this data, you can do like the previous one also, you can do the things. If you write here df1 and then you execute here, then also you can see the values here. Now you can see the values in the console. Okay, you can see the values in the console, and by clicking in the environment phases here, if you click, then in the top left corner you will get the, it will open a new window and it will show the values. So both the way you can view the results. So let's quickly practice one more data frame. That is data frame 2 we are taking. Here also we are taking three different variables. But here I'm doing one changes here. See, like that. See, we are doing the combining both categorical data and the numerical data. Okay, it is executing. There is no error is there. DF2 is executing. Okay, you can see here also DF2 is created, right? So now if you see DF2, see here all this, it is I'm changing here categorical data, so it is printed as a categorical data. Now the question is that when you combine this categorical data with the numerical data, then this 28 is now considered as a categorical data or the numerical data. That is the thing. So let's check, let's verify whether it is, what will be the index for 28. The index for 28 will be 22, right? DF2, because two number of rows and column number 2, so 22 will display the value 28. So let's check DF2, then 2, 2. Here you see this 28, and along with this 28 is working stored as a string. That's why it is printed with a double quotation. Okay, if you print another values, it will not be printed like that. So one more, if you want to print one column, complete column, then one advantage is there in data frame. What you can do, because here, suppose this one, you can see here, every column has one individual name. The first column name is the name, second column name is the age, and third column name is the marks. If you just print name, then all these Elias and Bob both will be printed. But for age, if you print age, both the data will be printed. But when you want to print a complete row does not have any name. This 1, 2, this is serial number, this is not the name. Okay, so for printing the complete row, you have to give the index, but for printing the complete column, you can give the column name. Here you can see df1 name, df1 this dollar, then name. If you, here you see in the bottom Elias and Bob is printing. But if you want to print the complete row, suppose first row, then what you can do, just you see, just I'm giving the index for the second row, and I'm not giving any column name or column indexes, then complete row is printed. This one I have already executed df2 2 comma nothing. Then that's this second row, Bob 2885, df1, this one Bob 2885. You can print the complete row. And if you give the indexes for individual cell, that one also you can do. Suppose 3, I'm giving here df1 3. Then you see 85 is printing 2 3. Okay, so 2 3, this one 85. Here you can see 85 is not coming with double quotation. That means it is a numerical value. When you are printing this 28, then it was coming with a double quotation. That means it is a string. You cannot do any mathematical operation with this 28. With this string 28, if you write 28 plus 1, it will be showing error. Okay, now I think the basic things of data frame, now you can get it. So now come to the next type of data structure, that is the table. Okay. Table is also one kind of data structure that is also like data frame only, but it is more advanced than data frame. Okay. This is a more advanced data frame than, oh sorry, data structure than data frame. So for here one thing, for executing the table function, you need to first install the table package. I have, and after installing the table package, first you have to load it before running. If I run directly this one, so if I run directly this one, tb table name aliases, this one, it is showing error here because I have not loaded the table packages. First you have to load the table package, then only you can run the table function, because table is not included in the basic R package. So this is stored in a different package, table package. So you have to load it. How to load it? For loading a package, you have to write library, then you have to write the function name. Now you see create table library, it is loaded, and after that if I run it, then it will be executed. Now it is not showing any error. And now one more thing, from where it will load, you will load this table function. First you have to install the table packages. Whenever you are getting a new packages, you have to first install it, and whenever you are calling some function from that packages, first you have to load it, then you can run it. So from where you can install it, you can go to here, packages, in the right side bottom, packages, then you can go to the install here. Okay, you can write here tibble. I'm writing here. See here, table is coming, table function is coming. So if you install it, and it will be installed automatically, but for that internet connection is required. It will be automatically installed. And in some packages it is not in the CRAN repository. So in that cases, I'm saying one thing, directly you go to the Google and you give one command, that give the installation command for this package. Say biobase package is not there, so give the installation command for biobase package. So it will give 3-4 lines command. Then this command line you copy from the Google, and then you install here, you paste here in the console. Here in the console you paste these 2-3 line commands and just press enter, and it will automatically install all these packages. So if you will not get the packages here, then you can manually download like that way. So now quickly go to the table packages, table function, how it works. Now you see this one, table, then name. After that we are taking one variable, then after that we are taking one more variable age. For that again we are taking one more vector C25 28. Okay, so if you see the values of tb, then you will understand what is the difference between data frame and table. You will get the difference by just observing the output. Here you see the output. I have run here this tb. In the bottom, in the console part, here you see these things, name and age, two different variables are there. For name, aliases and Bob, and for age, 25 and 28. But in between there, you can see here the character. What is the first column? This is a character. What is the second column? What kind of values are these? This is a double kind of values. Like you can see here in the last session already, these different data types are discussed: double, long, integer, okay, character. So age is what kind of data? It is a double kind of data. Okay, name is what kind of data? Character kind of data. So table also shows the types of data for each column, for each variable. So that is a very big advantage. Now it is showing very small thing, but when you are doing some real life example, in that time, it is sometimes it is required. Because what happened, suppose you are creating one vector of 1,000 values, and in that 1,000 values there is one string value is there, and it is by observing one by one, it will not be possible for a human being to find that one value. For that one categorical value in a vector of 1,000 values, all these numerical values will be considered as a string only or character only. So next, when you do some computational things based on these numerical values, actually this is stored as a character, so it will show some error. So in such type of cases, table gives some advantages. So basically table and data frame, it is the same kind of data structure, but table have some advanced features. Like this one is one advanced features. So one more table. Okay. Oh, this one is the next. So when we'll go for the data frame implementation with the real data, so we'll go in depth. So now quickly go to the next type of data structure, that is the list data structure. When you do the real analysis, mostly three different kinds of data structures are using. One is the very basic data structure, vector. Second, very commonly used data structure is the data frame. And third, very commonly used data structure is the list. List is also very widely used data structure. So list, what happened? In a list, you can combine 2-3 data frames, or you can combine 2-3 any number of tables also. So this one is a one kind of data structure list. So here, for creating a data structure of type of list, you need the function name list, okay, list, and this info is just a variable name. What kind of variable? This one, list kind of variable. Now we are writing here name as aliases, age 25, marks. For marks we are giving here. List is operating something like different way, for it is considering for each values. Okay, it is considering for each values. So suppose let's run it list. So here it is list. I have executed info. Here you can see here list. Okay, so now this is the list data structure. So here name, aliases is there, age is 25, marks is, for this alias marks are 80, 90 and 85. Okay, so for individual data, list is responsible for each data, but for data frame it is not considered like that way. So you can combine, more data like person. Suppose one more list data we are executing, that is list, name is aliases, age is 25, marks is this one. Just run it. So person is one kind of list data. Okay, here you can see. Then after that we can create one more list data, that is person 2. Let's execute it. Person 2, just a minute. Okay. Person 2, this is one more list variable. This one you can see This one is the for person 1, this one is for person 2. Okay, so now we can combine both the list into a single list. We are taking another variable, say info1, and we are combining both the list. We are taking the function list, person was 1 is equal person 1, then person 2, we are taking this person 1 and this person 1, both are different. This person 1, the first one, it is the argument for the variable list, and the second person 1, it is the this one. This person 2, it is the argument for this list, and this person 2, the second person 2, this is this one. Okay, here you see actually you can take any other variable also. Here also some different is there. One p is capital, one p is small. Both are completely different. Okay, when you are declaring a variable name, small differences will make a two complete different variable. So if you execute this statement, then both the list will be combined to a single list. Name info1. This one info1, it is created list of 2. You can see here 2 list, person 1 and person 2 are combined in a single list now. Very interestingly, list can combine any number of data frames also. Any number of data frames you can combine into a single list. Any number of lists also you can combine into a single list. So that is the power of list data structure. List data structure is the most powerful data structure in R programming. Okay. So now go to the next kind of data structure. That is the for time series data. For time series data, you need one function that is called TS. Here you can see TS. I'm writing here TS. Using this TS, you can you can store the time series data. So what is time series data? Suppose for a student in class 8, he has 6 different subjects. In class 9, same set of 6 subjects. In class 10, again same set of 6 subjects, and you want to store it. All other things are same, just the year is different or the class is different, class 8, 9, 10, but all other columns are, all other things are same, the subject names are same. So such kind of data are called the time series data. When we go for the medical data analysis, so we have taken the data for a same patient in the initial infectious conditions. After 1 month of infection, what is the condition? After 2 months of infection, what is the condition? Till whatever the possible, we want to take the data and we want to do the analysis. What are the different changes are coming? How the medicines are working? How the medicines are showing the differences, whether it is working or not. So nowadays, such kind of analysis are very, very crucial. It is going on in medical sciences. So time series data, for storing the time series data, we have one data structure that is called, that is we are storing using the variable TS. So this is the common values. We are taking one vector using the C, 100, 120, 130, 150. Then we are taking the start variable. Okay. If you next time, if you execute, it will automatically 2021. It will automatically, it will be in the next, for the next value, it will automatically be 22 for time series data. But manually, you can do add some more argument if you want 2 year of changes. 2000 once after 2020, if you need directly 2022, you can add some more argument, but by default it will be 2020. Then when you add the next data, it will be 2021, like that way. So here we are taking the frequency 4. That's why in the vector C we are taking 4 different values. Okay. Because in a year we can, if it is frequency 4, we can store change it to 4 different quarters. So if you run it, now sales, the data is sales. Here you can see sales from 2020 to 21. Automatically it is taking 20 to 21, 100, 120, 130, and it will be next will be 140. So you can see here, see the output in the console panel also, just by executing the variable sales. I'm clicking here and run, execute the sales here, quarter 1, quarter 2, 3, and 4 for 2020. The values are like that. Now if you add one more data in the same time series data structure, take one more variable, say new sales. Okay, in the new sales data, we are combining with the earlier variable sales. Then we can write it like that way, taking the vector like that, C, then sales. Okay, sales, that is the earlier our time series data structure, and after that 16, 170, 180, and 200, these are the new values for 2021. Because of these sales, it will be combined there. So now execute this one, this new sales. The new sales values are stored there. Then now final stage for combining the sales, these new sales we will store in the sales variable. So we can write here TS. Okay, TS, then new sales we are writing here. Instead of the values, we are writing the new sales. Already we have linked these new values with the sales, but for this start 2021, for this continuation, again you have to write this statement, new sales, then start 2000. Again we are writing the same frequency 4. So execute this one. It is executed. Now let's execute the sales variable, what it is showing. Now you see here, when I am executing the sales, now there are for two different years it is showing the values. So like that way, time series data, TS function can store the time series data. Now quickly go to the last type of, that is last kind of data structure, that is called factor data structure. Okay, factor data structure is not much complicated to all these things. It is a simple and clear data structure, that is factor. That is, say you have one column of, in every column it is writing a few keywords are repeating. Suppose male, female, or all this like that. Suppose take one different example. One vector is there which have repeatedly giving the same values, say boy, girl, boys of below 10 years, boys of years 10 to 15, age matured people, like that. 5, 6 repeated values are there for a vector of size 1000. Now when you want to give some level for this, suppose you want to find out how many unique values are there. So in that cases, to find the unique values from that vector of 1000 values, if you insert the complete vector, if you insert, this is the complete vector, say inside the factor data structure, then repetition will be automatically excluded, and only the unique values will be stored in the variable. Say whatever variable you will declare, I am declaring here the variable gender. So if you now execute it, this statement is executed. Now print the gender variable, run gender. You see here gender, now it is giving the all values, male, female, the complete This one is storing in gender. After that, if you give here the levels, because this gender is a factor variable, after that if you give the different next command level, then you can see here the levels are actually this not 4 different values, actually it has 2 different values, female and male, all are just repetitions. So such kind of data structure is also required to store the basically to store the levels. Okay. So these are the different basic data structures. And one important, very important command is there, rm list ls. This one is for clearing all this environment. If you run this one, rm list ls, instead of running directly complete command, let's take rm, and inside this rm, if you give any variable, say df, so df, I'm writing here df, and after that if you execute this one rm df, then you see df is deleted from here, from this environment. Now df is not there. Again, say df1. If I write here df1, now you see a df1 is there in the environment variable. But if I type here df1 rm df1, if I execute this one, this df1 will be deleted. See here, df1 is deleted. Now there is no df1. And if you want to delete, or if you want to clear the complete environment, if you want to basically, if you want to delete all the variables, then you can write here rm list ls. If you execute this statement, complete will be erased. See here, the complete will be erased. Okay, I hope everybody have got a basic idea of different data structures. There are basically 7 to 8 different data structures available in R. So let's go a quick brief. So the first, these are the different data structures. So first we have discussed the vector, then we discussed the matrix, then we discussed the array. Array can represent vector as well as matrix also. Then we go for the next very common data structure, that is PPT. Is this visible for everybody? Am I audible to you?
Yes, sir. It's visible.
Oh, okay, okay. So next is the data frame. Then we discuss the table. Then there is the, I have already told what is the difference between data frame and table. So now the next data structure we discuss the list. Next data structure we discuss the time series data. Then finally we discuss the vector data, right? So now after discussing all these data structures, if you are interested, then we can go for a real life programs or real life implementations, how it is used using a, because we are taking only taking we are using here very small inputs, but when we have to, we are going for the real life analysis, then in that cases we have to go for the bigger data sets. So in that cases, how these data structures are using. So let's quickly go for this real life, using one real life data sets. So now again come to the R Studio. So here let's discuss one real life program, that is how it is using. So here in a real life program, we are generally we are showing write the get WD to check the path for this program, because we have to access the real life data sets. So let's run it one by one, step by step. We will run it. Get WD run. Okay, we can see here the path. Then after that, you have to, this is the data set. Okay, so this is the real data set that we will fetch from our computer hard disk, and we are storing this data set. This is in CSV file, and it will store in one variable, that is DEZ SRP064894D. We will store it there. So after storing, we can see here this, just keeping the mouse cursor here, we can see what type of data structure it is. Now DEZ, this variable is a data structure of like data frame. It is a data frame data structure. You can see here one pop-up is coming. By clicking here, we can see, we can visualize the data. Here there are 2720 observations are there, and 16 variables are there. Here all columns are considered as a one variables. 16 different columns are there, variables are there, and these are the different observations, 2720. So this is the real world data. So how data frame can be used in real world data, these things we'll see here. So for the implementation of these things, whatever the implementation we are doing here, we need one different packages that is called biobase. Biobase package, I have already installed it directly. I load it using the library function, library biobase. I'll run here. Okay, here you see welcome to bioconductor. It is loading, that means it is loaded. But if it is not installed in your computer, then you have to install it first, then only you can load it. For installing, you can go to this install, click here. If you can get it biobase here, then you can install from here also. Otherwise, you can manually, you can download from the Google. If you write in the Google that give the biobase installation command, it will give 3-4 lines command, and you paste here, just press enter, and then automatically this biobase function will be loaded. After that, this is the variable where original data is stored. So this one, now we are not doing the manipulations, or will not do the analysis directly on the original value. We are storing these values in a different variable. We are named as gene data. So execute it, gene data. Okay, we got it. It is gene data. Then DIM. This is one function for verifying this dim function is for verifying what is the dimensions of this data. From here we can see that dimension is 2720 into 16. So from here console here also we can see by writing this command, yes, we can dimension is 2720 into 16. Now here, just what this program is actually doing, I'm not going to tell all these things because this will not be possible for here. I am just telling here how to do different manipulations, how to do different operations using this data. Okay, so how these different functions are working. If you can understand the complete program, what it is working, then it is very nice, very good. So here you can see here gene data $symbol gene symbol. That means gene symbol is our first column. This one, first column is our gene symbol. This first column gene symbol, we will convert it into the row name. Now presently, what is our row name? Our row name is just 1, 2, 3, 4 like that. So we will remove these row names with this gene symbol. Okay, we'll replace this 1, 2, 3, 4 with this gene symbol. So let's execute this one. And now gene data, this one is the gene data. Here now we can see this one. Initially this was 1, 2, 3, 4. Now we can name it as this one. So why we are doing these things? Because you can see here all other columns are numerical data except from the first column. When we do some numerical operations, because of this the first column, this is a categorical data, it will not be possible to do the calculation part, computational part. That's why, but this gene symbol, this is also important features. We cannot delete also. That's why we just replace it from the actual data set to the column name, so that our feature is also there, feature is also present, but it is not affecting our calculation also. Now what we will do? Now this is already repeated data. So first column gene symbol, that first column we can delete. If we delete, then also no issue. Data is preserved already. So for deleting the first column, what we are doing, gene data, and this is the new data. And what we are doing, gene data C of -1. Using the C of -1, we are deleting the first column. And after deleting the first column, the new data is again stored in the gene data variable. That means the new data is going to replace the original data. Let's run it. Now gene data, you can see here. See, the first column is replaced. The first column gene data is replaced and all the numerical values are there. So now we will do the transformation. How to do the transformation? Row to column, column to row. You can do it by manually also, by doing the for loop, one for loop inside the for loop. You can do the transition like that also. But directly one transition function is also there in R programming, that is T gene data. Using the T gene data. Now here one thing, initially this gene data T, this gene data, if I place the mouse here, it is a data structure of data frame, but after transformation it will be changed. You see here it will be changed. Now I have executed it. Now gene data is changed. Now you can see that this gene data is automatically converted into matrix. Here in pop-up you can see it is matrix. Now it is not a data frame. Okay, so now since matrix is not convenient for all kinds of operations compared to data frame, you can continue with matrix also, but matrix does not support all kinds of operations. That's why we will convert this matrix again into a data frame. How to convert it? This gene data, this is the function as.data.frame with gene data, then it will be converted, that gene data matrix, into a data frame, and it will be again stored in gene data. Okay, now it is stored in gene data. So now again you can see gene data is a now data frame. Now after that we'll do one different operation. We will create one correlation matrix. For creating the correlation matrix, by default there is one function is there, COR. This, it will create the correlation matrix for this data. So correlation, this by default COR function will give the correlation of Pearson correlation. There are so many correlation functions are there, but by default correlation function will calculate according to the Pearson correlation. We will calculate the Pearson correlation for this one using the core function. Okay. There is a warning. It doesn't affect anyone because there are so many zeros are there. That's why it is showing warning. But it can be actually there. Somebody is messaging. Okay. Then now after that, again we can see the dimension of my correlation matrix. Here, my correlation matrix dimension will be different than the original data frame. Here you can see it is 2720 into 2720, because when you create a correlation matrix, if I consider in this data, it is 2720 into 16 dimension variable data set. If you consider this 16 for correlation, then correlation matrix will be 16 into 16. But here we consider all the genes for correlating her, since there are 2720 number of genes, so correlation matrix are 2720 into 2720. Now this is we are taking one more variable to do the implementation, so that original values are become as it is. We are taking the values to a different variable. After that, we are calculating the number of rows and number of columns of the correlation matrix using the function n row and n column. Okay. N row and n column. We are executing it n row and n column. And after that, we are going to calculate the degree of each gene. Now in Pearson correlation, what we do, we usually do one thing. Pearson correlation values are in the range of -1 to 1. So from -1 to -0.5, generally we consider as a 1. And again, after that, 0.5 to 1. These two ranges we consider as a 1 when you have to convert it into a binary 1. And the middle range, -0.5 to +0.5. This is near about 0. That's why we consider all these values are as a 0. So for implementing like that, we are writing one condition here. Like that, we can write else if condition, if conditions. We are doing so many manipulations are here, data management are here. We are running one while loop. Inside the while loop, again we are running another while loop. Inside that, we are giving the if conditions. Initially we are checking whether there is any, means missing data. If there is any space is there where no data is available, if there is such space is there, then it will also give some error if some blank space are there. So if it is true, if it is NA, then we will write it, consider it as a 0. Then after that, we will do the actual calculation. We will check whether it is below or in that range. If in that range, then we will consider as a 1, and otherwise we will consider it as a 0. So like that, we can convert the Pearson correlation into a binary matrix. So this logic is not important, but how this logic is implemented in our data structures using the data frame. All these are, you can see, all these are data frame only. My correlation matrix, my correlation binary matrix. Am I visible to everybody? Our studio screen is visible to everybody?
Yes, the screen is visible to everybody.
Okay. So after that, if it is not beyond the condition, then we considered it is a 0. So like that way we can do the different conditions. So now let's execute this one while loop. Here we can see in the console panel, we can see how it is running, because we are giving here print function, print I, because of this print function.
Sir, sorry to disturb you. I just
Sir.
wanted to yeah, say about the time. Like we have around 15 minutes left for the session.
Yes, madam, I'm just about to complete it. It
Sure,
will
sure,
take
sir.
hardly 5 minutes.
Thank you.
Okay. So after that, one more data frame we are again creating. So whenever you are storing the data directly, it is converted as a data frame. But otherwise, you can create a blank data frame also. For creating the blank data frame, you can run it like that way. The any variable you can write here and data frame function using this. And after that, again, n row and column for calculating the degrees. These two functions are we are writing. So for calculating this degrees, so we are giving here, if there is 1, then we count it as a edge is there. If there is no, if it is 0, then we consider there is no edges. So in that cases also you can do the manipulations like that way. So I am showing here how data frame can be manipulated, how data frame can be used for different analysis. So let's run this program also, this segment also. So now all these data are stored in the data frame df. Okay, so here one last very important crucial thing is I'm going to say, that will be the last one. So this df data frame, you can see here the column name is just by default it is coming as a v1 and v2. Now we are going to rename this. How to rename it? So column name, this function you can write here, call names df1. Whatever the name you want to give, we are giving here zin symbol. So let's execute it. Column name df. So now you can see here this one, it is converted to zin symbol. Then for the second column also we will convert it to degree d. Execute it. Now it will be changed to degree d. So like that way you can change the column name. Then finally this df data frame we are going to store physically in our hard drive. So for that you can do you can command it write function write.csv. So this is the data frame and this is the name that you, for that name using this will be the name of the file by which it will be stored in our hard disk. So let's execute it. So let's give some different name, say ABCD. So it will be stored it like a ABCD. So after that, okay, it is also stored. Now you can see that ABCD file there also. Here you can see the ABCD file. I am sharing this one. Here we can see the file name ABCD. It is stored here. So that was completely same as the DF. Okay. So with this, I would like to conclude the session. So we have discussed 7 to 8 different kinds of data structures, and using one real life data set, we have do the different data analysis. Also different kinds of data structures, vectors and data frames are also using. So since there is a time constraint is there, otherwise we can go for the list and other data frames or other data structures also. But due to the time constraint, will. But now you can understand the how data structures can be used. So you can by go through these things, you can analyze the other type of data structures also. Okay, thank you. Any questions, please?
I request the participants to ask clear their queries and doubts if they have any. You cannot see any question in the chat box. You can unmute yourself and you can put up the question directly to the expert. Any questions from the participants?
Yeah, I hope actually everything step by step it was directly showing it was an implementation. So there was no theoretical part.
Okay. Yes, I think so. In case you all have any queries, you can directly contact sir. Sir, if you can just share your contact details with the participants in the chat box, they can directly connect to you if they have any queries or doubts. They can clear it later
Okay.
on.
Yeah. Okay, I'll share with that. You can directly contact me to through the email ID. Okay, and I think in the flyer also my email ID was there, so you can
Yes,
contact from
yes.
there also through the email ID.
Okay. So
Okay.
it was a very enriching session, sir. Very lucid way you have explained very big concepts, especially for the background of social science. It's not that easy for us to use this kind of softwares, but the way you have made it easily understood to us, that is really great. It was a
Thank
very
you.
good session. You spared your valuable time to explain us how the things work, how data structures and management can be used in the research world. Our research scholars and our faculty members are really benefited. Thank you so much, sir, for your presence. And we hope that we will be able to organize more of the sessions and get you here in the sessions. Thank you so much.
Thank you so much. Yeah.
So, we have come to the end of day one. We have completed both our sessions, session one and session two. Session one was delivered by Dr. Ambar Datta from MIT University, Kolkata, and session two by Dr. Vikash Bora from Royal Global University. Tomorrow again, we have our session three and session four to be delivered by Dr. Jiten Singh from ICMR and Dr. Burman from Dibrugarh University. So our session will start at 11 o'clock. From 11 to 1, we have session 3 and we have our session 4 from 2 to 4. So I request all the participants to kindly join tomorrow and enjoy the enriching experience of gathering knowledge from our experts. Thank you so much.
Yeah. Thank you.